Even though the concepts, practices, and principles related to DevOps are not only limited to the world of cloud, DevOps itself has a lot to do with the cloud. In fact, the origin of DevOps is from the cloud world, where it started as a mere discussion to resolve the conflict between the developers and operations who were part of mostly the companies which were purely built on the cloud in around 2008 onwards. So from that perspective, understanding cloud computing, understanding the concepts related to cloud and what make the fundamentals of the cloud computing is essential for a DevOps engine. In this section, we're going to begin understanding of what cloud computing is, where all it came from, how it all evolved, and what are the advantages of using a cloud. And it could be a public cloud or a private cloud. In this lesson, we're going to learn about the evolution of cloud. And our story goes back to 1960s when a professor from MIT, John McCarthy, predicted that time-sharing model will result in future where computing power will be sold as a utility. And that actually forms the fundamental tenet of what cloud is all about, right? And he predicted this in 1960s when he was at MIT, and that is what is happening today with the world of cloud. And if you look at the way it all evolved, earlier we used to have mainly these supercomputers or the larger computers where we had one big computer occupying possibly a whole building. And in around 70s, we started with distributed computing model, where instead of this centralized processing capacity or unit, we started distributing it across the nodes, right? And treat it as a collection of computing units which are interconnected, and they work together to provide a service. And that's the fundamental tenet of a distributed computing model. And distributed computing can be of two types: either the client server model that's been popular for a while now, or a P2P model, which you might be familiar if you're using Skype or torrents and so on and so forth, right? Now, the advantages with this distributed model, where instead of having this one big computer, you are doing a distributed computing. And once you start doing distributed computing, we also started commoditizing the hardware required for that, right? And that's where IBM came in, and rest of the companies started building softwares on top of that. It is also high performance. You can achieve a better performance with that distribution at a cheaper price. So it is definitely cost effective. And since we are not going vertical in terms of the scaling, it's easier to add more nodes, more clients, to add more capacity. So it is definitely a scalable model to use to do that in a distributed way. Now, with these advantages came in some of these challenges, and these challenges still exist in today's world as well. Mainly to do with security, because once you start distributing, you start communicating over the network, so you have to think about security. You need to think about encryption, firewalls, and so on and so forth. The second is the connectivity, right? So it started, the internet started evolving around the same time, and we also had local area networks, the WANs, and so on, right? So we need to start thinking about a network and the connectivity, the concurrency that your distributed model can support, as well as the fault tolerance, because if your server goes down or if one of the node goes down, what happens, right? So those challenges are the ones which still need to be handled in today's world as well, and that's since the beginning of the distributed computing. Now, we started buying this hardware, doing capacity planning, and then what used to happen was we would buy the hardware generally based on the future capacity, and we would end up wasting a lot of resources. So you would underutilize and over provision the hardware, and to optimize that, I believe in 70s, we started or we came up with a concept of virtualization. Now, virtualization changed a lot of things, and that is also the one of the fundamental technologies used in the cloud as well, because cloud is nothing but a way to create virtual machines on demand in a managed environment. Now, what virtualization gave us was an optimal utilization of the underlying resources, your CPUs and memory and so on. So even if you over provision the hardware, it's okay. You could add a layer of hypervisor on top of that. You could run multiple virtual machines. So you could actually scale up your capacity using the virtual machines, and that would also save you a lot of money. And you could get the best bang for your bucks using the virtualization technologies. As we talked about, virtualization also fueled or is the fundamental of the cloud computing. And if you talk about cloud is nothing but a shared utilization of computing resources, and it's not limited to computing anymore. It's the storage, network, and all of these infrastructure components on demand, right? So with cloud, we're not restricted to only the hardware that we have at Aravel. It gives us a sort of a utility model, and if you compare it with the utility model, let's say whenever you construct a new house, you don't go and build the power generation or unit and the power distribution units. That you don't need to do that. Somebody else has done it for us. And that somebody else in this case is generally the government, who who has the power plants, and could be hydroelectric power, could be wind power, could be any of those forms. And there's also a power grid to distribute the electricity and bring it to your home. So all you have to do is just get a power line, use as much as you want. You never have to worry about, okay, if I buy a new device or a new appliance, where does the power come from? You don't have to worry about that. You just use as much as you want, and at the end of the month, pay based on the number of units that you consumed. And that's exactly what happens with cloud as well. With cloud, we're using a utility model in the world of computing as well. So you use or you provision as much as you need in terms of compute, network, storage, and various other things. And at the end of the month, you pay based on the units that you have consumed. It could be in the form of number of hours, or it could be in some cases the minute per minute billing as well, right? And that's what cloud brings in to the table. Now, in the next lesson, we're going to learn about the benefits of the cloud. So let's get started diving into the world of cloud. In the previous lesson, we learned about the evolution of cloud. We also talked about the utility model that cloud brings in to the world of computing, where you can provision as much resources as you want and pay at the end of the month. Now, we'll talk about the advantages of cloud, both from the business perspective as well as the technology perspective. From the business perspective, cloud has a great advantage where you move the expenses from operational expenses or capital expenses to the operational expenses. With capital expenses, you have to invest a lot of money right up front. Whereas with cloud, you don't have to do that. You use as much as you want. It also reduces the risk of running a business, and that has what has enabled a lot of new companies with new ideas to try out new things and build their products on the cloud. The economies of scale is another advantage where, just like the power generation, you don't have to build the power generation unit yourself. If everybody would have to do that, it would be much more expensive to build your houses and continue with that, right? Instead of that, somebody else does that for you, right? So that's the government who builds the power plants in spending millions of dollars. And now the same thing happens in the world of cloud as well. So it's the cloud provider who has built that infrastructure at a scale, and they would have invested like millions of dollars doing that, and they pass on. And when you do that at that kind of a scale, you can actually get a lot of economical benefits than rather than building everyone building their own infrastructure there, right? And the cloud providers can pass those cost benefits to their customers as well, and that's the economies of scale that we could achieve with the cloud. Another big advantage from the business perspective is you stop guessing about the capacity and the investment that you will have to make in your infrastructure, because you don't have to worry about how, where the resources come from. It is all on demand. And whenever you need, let's say tomorrow you need 1,000 servers just for one day, you don't have to go and buy those servers and wait for like months for those to be provisioned and to be ready. You can just use it, and once you're done, you can just give it back to the cloud provider and just pay for whatever usage that you made. It also gives you an increased speed and agility. Just like as I mentioned, you don't have to worry about where the capacity comes from, and it is all automatic, it is all programmable, and it is immediate. So it gives you an increased speed and the agility, and you can get started being productive in a day. You can in fact release your application within a day, provided that your code is already available on the cloud. You also don't have to worry about expenses that you would incur if you have to build a data center, or even if you have to use a co-located data center services and buy the servers, have people to maintain those servers, the hardware, have someone to go in to be physically present and to manage those servers and so on, right? So you have all these incur expenses. In fact, if you have to build data centers, you also need to think about the networks, the routers, switches, internet, the power, the air conditioning, the physical security for your racks. None of that is needed if you are using cloud. And what is even better is you can go global in minutes. Since most of these cloud providers have not only built the infrastructure at scale, they have built it across the globe. They have regions across the world, right? And if you want to host your servers in America versus Europe versus Asia Pacific versus anywhere you want to host your infrastructure, you'll mostly find the cloud providers having a presence there, right? So you can actually go global within minutes by leveraging the cloud. And all of that is on demand. So it's pay as you go. So you don't have to invest in advance, and you use as much as you want. And at the end of the month, you pay for your usage. And those are some of the business benefits. Let's look at now the technology benefits that cloud brings in. The biggest benefits that cloud brings in is the self-servicing and the automation. The ability to self-service is a big thing, because you no more need people to go and provision the server for you. You don't have to have a special team to do that. Developers should also be able to go and provision their own development infrastructure, and all of that is possible with the cloud. Apart from that, there are APIs. Everything in the world of cloud is software driven. So it's software defined network, software defined compute. So since it is software, it can be automated. You have APIs, you have libraries, you have specialized tools to provision the infrastructure on the cloud and talk to the various clouds. And that gives you an immense ability to bring in the automation. And that actually has fueled the growth of DevOps as well, because with DevOps we actually talk about a lot of automation, and that includes the provisioning on the cloud as well. It gives you a way to automatically scale based on the request or based on the demand that you incur. So you can actually have a programmatic configuration to add more capacity when you need it. Let's say you have 1,000 users now. If suddenly, let's suppose you have 10,000 or even 100,000 users, you can scale according to the number of users that you need to support, and cloud gives you an ability to do that. It also gives you an efficient development and DevOps cycles, the way to test things. You don't have to worry about where do I provision an infrastructure for testing. It could be an automated test environment that you can create, run your test and get done with immediately, and just pay as much as you use. It also gives you a way to do the disaster recovery, migrations, and so on. So since you can have infrastructure located in different regions of the world, even if there is a, let's say, natural calamity in one of the regions, and even if you lose one data center, you can always have another setup running in a different geographical region as well. With the geographical regions, with the ability to automate things, your disaster recovery becomes much easier in comparison. And you can use it as an overflow as well. Let's say you have your own data center, or you have your own private cloud presence. You can actually use the public cloud just for an overflow. Whenever you need more capacity, you can just go to the cloud, otherwise run. So you can have a hybrid model of running your infrastructure as well. And those are some of the technical benefits that the cloud offers. So we talked about the business as well as technical benefits. In the next lesson, we'll talk about the types of clouds and various models. So in this lesson, we're going to talk about the various types of clouds which are available, as well as some of the examples of each. So cloud computing is generally categorized as these types, right? So there is a IaaS, which is infrastructure as a service. There's a PaaS, which is platform as a service, and then there is SaaS, which is software as a service. Now, which one is which? Let's talk about that a bit. So if you talk about the most of the softwares that we use on the cloud, it could be right from Google, Gmail to your accounting softwares on the cloud, to your right from the mail clients to the browser based anything that you access from the browser, any application, any kind of application that you use is generally an example of software as a service. So most of that falls under software as a service. Now talking about platform as a service, it gives you a more control over your environment. If you're a developer, you basically need an environment to run your software with, but you don't want to be bothered with all the infrastructure components underlying. You don't have to worry about how do I provision a server, how do I install the environment. If I need a complete environment to be there, and if I have a code and I could just plug it in there, that becomes a platform. An example of platform as a service is Google Application Engine or Google App Engine, where you can write the code, you can host it on the cloud on Google App Engine, and it will provision the environment, it will run on its own. So you don't have to worry about the scalability, you don't have to worry about how do you set up that environment, somebody else has done it for you. So there are many examples of platform as a service. There are examples such as Cloud Foundry, which is again a PaaS solution or a platform as a service solution, where you just bring in your code and just plug it in there and it works on its own. Then if you need more control over the infrastructure components as well, let's say you want to build your own infrastructure, you want to decide how it scales, you want to define the parameters, the configuration, optimize everything. If you need more control and if you have a capability to do that, to manage that infrastructure, you would generally choose an infrastructure as a service. And talking about infrastructure as a service, most of the cloud platforms, public cloud platforms, are focused on or started with rather infrastructure as a service. That includes AWS and a lot of services related to AWS, including EC2, S3, RDS, the network services, and all of those give you an infrastructure. And you consume that infrastructure, you build your own applications on top of that, you host it yourself, and then you manage it yourself, right? So that's the infrastructure as a service. However, you don't have to build that infrastructure. Somebody else has done it for you. For example, AWS builds the data centers for you, and they have the networking, the routers, internet connectivity. Everything is managed by them. You consume the infrastructure when you talk about infrastructure as a service. When you talk about PaaS, you consume platform. So you don't have to worry about underlying infrastructure. You have a complete platform to run as. And when you talk about the software that we consume directly, we don't even have to worry about writing the code, or we don't need to do that. And that is where the SaaS applications come in. Most of the browser-based applications that we use are SaaS platforms. And we have come a long way from the time when we used to install all the softwares on your systems, and now it's not needed anymore. It's the services that we consume, and that's the software running on the cloud. Now, talking about the deployment models, there are mainly three categories here. Most important, most popular being the public clouds. Now, in case of public clouds, we generally go and deploy it on a platform that is available publicly, and we can create an account and we can consume resources given by that public cloud provider. In this case, we don't have to worry about any infrastructure components. It is all provisioned and provided by the public cloud platform. Most popular examples of public cloud platforms are AWS, that is Amazon Web Services, or Microsoft Azure, that's another one. Google Compute Engine is the third one, which gives us a lot of these infrastructure components, right? These are all examples of public cloud. Apart from these, there are many other cloud platforms like Rackspace and DigitalOcean and so on and so forth. Now, if you want some of the features of the cloud, that is self-serviceability, automation, but you still have your own infrastructure, you may want to build a private cloud. Now, why would I build a private cloud when I have, let's say, existing virtual environments? Is the ability to automate, that's one. Second is the self-serviceability, whereas your developers can go to the cloud platform, request for the resources, and it gets provisioned in an automated way. So that kind of self-serviceability and automation is also important for a lot of companies, and that's where we bring in the features of the public cloud and start implementing it in our own data center, in our own environment. In some cases, we have a hybrid model where we use public cloud for mostly the overflow, or when we need more capacity, or we run some part of our application stack into the public cloud. Rest is built and hosted inside our own environment, that is the private cloud. Right, so that's the hybrid model where you use capacity, exceeding capacity. For exceeding capacity, you need for excess capacity, you would use the public cloud platform. And a lot of companies start with the public cloud model, and after some point of time, after a certain kind of a growth, they start thinking about bringing in their own data centers, and they use public cloud as for mostly the overflow. And those are the deployment models in terms of the cloud space. Let's also look at some of the important milestones in the world of cloud. Now, 1999 was when Salesforce was launched as mostly the software as a service. That was the first type of a cloud service which came in. And then came in AWS in 2002, but they launched the services. There was only one service that they started with. I believe that was S3, and then they brought in their EC2 service, where you can actually host your compute units or the virtual machines on the cloud, rather. That is Elastic Compute service, and that is what made the cloud platform really popular. And after that, we saw a huge growth of new companies, which wouldn't have been possible if we had no cloud, right? Because we didn't. And now anybody who had an idea could try things out on the cloud, and based on that, some of the companies who found success grew to a very large extent on the cloud platform. And that was where it started getting really, really popular. And after that, 2008 was when Google Compute Engine was launched, and Microsoft followed this beat in 2009 with Azure services. And at this point of time, AWS leads the space of the cloud computing, and Azure is the second most popular one, followed by the Google Compute Engine, as far as I understand. Now, talking about cloud and DevOps, how it all goes together. Now, even though DevOps practices and principles, including infrastructure as a code, the continuous integration, optimizing your throughput of your system completely, does not limit itself to the world of cloud. As we talked about, the DevOps originated in the cloud world, and it finds its own comfort in the world of cloud as well. Because when we talk about cloud, it is essential to use automation, and the reason why we use cloud is basically it gives us one of the important reasons is it gives us an ability to automate. The other thing that you would note is a lot of companies, a lot of startups start with the cloud because they just have an idea and they want to try it out, and if they succeed, some of the successful startups have seen tremendous amount of growth in a very short span of time. And when you have that kind of scale, in making, you definitely need an ability to scale really fast, build that infrastructure, and you cannot do that without some of the principles and practices of DevOps, including automation tools like provisioning automation tools like Terraform and CloudFormation, Ansible, infrastructure as a code tools again like Ansible, Chef, Puppet, because when you want to build that kind of infrastructure, manage it with the least amount of efforts, with probably very very small team, you definitely need automation. You definitely need the DevOps skills there, right? So even though DevOps is not limited to cloud, it becomes an essential part of building, managing infrastructures on the cloud, as well as it is the one which is fueling, they are both interdependent. So DevOps is fueling the growth of cloud. Cloud has started the principles and a lot of automation tools related to DevOps. So that way, they go well together. In the previous section, we talked about the fundamentals of cloud computing. What is cloud computing, how it all evolved, what are the advantages, and what are types of clouds. Now, talking about the types of clouds, there is a public cloud, and then there are private cloud platforms as well. Now, the first cloud platform, the public cloud platform, and also the most popular one, is by Amazon, that is Amazon Web Services, or also known as AWS. Now, with AWS has global presence in 14 regions. There are each region has different data centers, which are also known as availability zones. So if you look at this chart right now, it has 16 geographical regions, which are out of which 14 are available for general public. 2 are restricted regions. One is China, second is the AWS Gulf Cloud. And it is also launching 6 new regions which are coming soon as well. With this global presence and the type of features and the services that AWS offers, which are these are just overwhelming set of services that you could imagine to be available for every type of entity and kind of application that you may have. In this section, we're going to introduce you to the primary services, some of these important services that AWS offers, and by the category of services really, because there's just an overwhelming set of those. So let's get started diving into the world of AWS with the introduction to basic services. Alright, so let's begin with some of the most important AWS services. As we discussed in the previous session, AWS just has overwhelming set of services. If you go to the aws.amazon.com and look at the products, there are different categories and types of services which are available. Let's say for compute, there are a bunch of those. For storage, for databases, those are managed databases, migration services, management tools, developer tools, network and content delivery. There are new tools for artificial intelligence, analytics. There are, specialized services for security and compliance. If you're building mobile applications, there are a few things which are quite useful for you. And in terms of business productivity, desktop applications, IoT, right? So you ask for it, AWS probably already has it. Now we'll talk about few of the most important categories, starting with the compute. Talking about compute, one of the first services and the most important ones is the EC2, where EC2 stands for Elastic Compute Cloud, where you can provision VMs and run VMs in the cloud. This is basically in a self-serviced way, so you can create an account, you can provision the servers, you can run those, you can connect to those, you can destroy those. So it's elastic. It's called as elastic because you can provision as many servers as you need. So in terms of the capacity, it offers you that kind of a elasticity based on your requirement. And apart from EC2 services which are related to the VMs, you can also avail auto scaling, which is also part of the AWS EC2 services. You also have or get elastic load balancers, either the application load balancers, internal load balancers, or external load balancer. There are different types of load balancers which you could avail along with EC2. That's primarily to run the VMs in the cloud. The second type of service, which is also very interesting, this is a new service introduced in the last few years. This is also the one which is fueling the growth of serverless computing. Now, we can always host the host your servers on EC2, that's right, to run your application all the time. However, there are situations where you may not want to host any application all the time, but you may want to run it on demand. And that's where Lambda comes in. So Lambda allows you to write your function. So whatever you want to do as part of the processing, you can write it as a function instead of running a server constantly, managing it, monitoring it, and you just trigger that function when you need it based on some event. And that event can be somebody clicking some application or maybe a checkout button on your e-commerce site, which triggers a function and it does some processing, or it could be an IoT device creating some generating some event or some metric which needs to be processed and stored in a database. So any of these kind of processing can be done without servers, by running just the functions. Obviously there are servers, but those are managed by AWS, so you don't have to worry about the capacity, you don't have to provision the servers or monitor those, and you pay per request. So you may have 1,000 requests today, or you may have 100,000 tomorrow. You never have to worry about the scale, and that's a very interesting concept, and it's a very interesting service as well by AWS. The third service, which is also interesting from the compute perspective with the advent of Docker, is ECS. And ECS allows you to run containers on top of those EC2 instances that you provision, and it gives you a way to orchestrate those. Now, if you have heard of Docker or have been using Docker, Docker is a great tool to build your application, package it, and run it locally. However, when you want to deploy Docker on a bunch of servers, let's say you have 100 servers, 100 EC2 instances, it gets complicated to manage and decide where to run the next batch of containers. That's where ECS comes and saves the face, because it creates a cluster out of the available set of EC2 instances, and it makes the decision where to run it. It lets you orchestrate your Docker containers at scale and a production grade environment using this particular service. And those are the three important compute services. Apart from these, there are a few new services that AWS has introduced, including the Lightsail, which is like running VMs similar to DigitalOcean. You can run your virtual private servers on the cloud. VPC is part of a networking service, I would say. There is a batch processing. If you want to run a batch or do the batch processing, you can run application directly or as a PaaS platform, that is AWS Beanstalk. Lambda is what we have looked at, and those are the part of AWS compute services. In the previous lesson, we talked about the compute services, which is the primary service provided by AWS. Now, in this lesson, we're going to talk about some of the storage as well as database related services. The first being the S3, and this was actually the first service launched by AWS in, I believe, in around 2002. And S3 allows you to, it's an object store, meaning it allows you to store objects or files in on this basically a sort of a storage service, right? It's not a block store. Block store is like a hard disk. Block store is similar to the service offered for block store by AWS is called as EBS, that is Elastic Block Store. Elastic Block Store is like attaching hard disk to the running instances, whereas S3 is a completely different type of a storage service. It's a object store where you can store as many files as you want. It is not an hard disk. It is mainly a storage service. In fact, there are other services which are built on top of S3, which is similar to Dropbox. So Dropbox earlier was completely hosted on S3. And Dropbox provided an abstraction on top of this S3 service, right? So you can actually store anything. It could be any files and any artifacts, any binaries that you want to share with the world, or it could be some static content for your website. So all of that, images, videos, anything can be stored on S3 as an object store, right? It's a store where you store an object and retrieve it either using an API call, using a browser based URL, or you can use some libraries to fetch the objects, or some application to fetch an object from this S3 buckets. And S3 has a concept of buckets to store all these objects. The second service which works along with S3 is Glacier. S3 also is like, if you talk about S3, coming back to S3, it is also a high available, highly redundant service, right? It gives you 11 nines of guarantee. So it's 99.9999, that is 9 times percentage of uptime is what it guarantees. And every object that is stored in S3 is replicated thrice. So every object has 2 replicas. So there is a replication factor of 3. So the object itself and 2 replicas. Now, if you are looking for S3 itself is quite cheap, but if you're looking for even cheaper object store, which you do not, which you can use for storing information which you do not use very often, that's Glacier. Now, Glacier is an archival tool. So instead of storing tape backups, if you have any data that you need to archive, you would use a Glacier. And this can be, let's say, for compliance reason, let's say a medical field, you have a compliance it says to maintain, and you may have to keep every single record for up to, let's say, 10 years or so. Now, you don't always go and look at it very frequently, those records, but you need to maintain it or store it as an archival so that you can retrieve it when you need it. And Glacier is this kind of a service which is 1/3 the cost of S3, so it is really cheap, and you can use it mainly for archiving objects which you can retrieve when you need it, but it is not available immediate. That's the downside of using Glacier. So you have to send a request and it will be available in few hours. It also works seamlessly with S3, so you can define S3 lifecycle rules saying that you maintain these objects in S3 for some time, and then you send it to, after let's say 3 months, you send it to archive. Now, what do you use archival service for is to store the data that you don't want to use very often, like compliance data, the records that you want to keep. You may want to, let's say, you may have a service where you have a video streaming service where you store the content. The original content is then transcoded into different formats which you generally stream. So the original video is not needed very often, but you still need to store it somewhere, and that's where you use Glacier and services like these for. Now, along with this, there's another service which is also very useful, that is called as CloudFront. CloudFront is a content delivery service, content delivery network. And that's an interesting concept because, if you have heard of Akamai or services like that, what they do is you have one server globally like one origin server. Let's say you want to stream an event. If it is, let's say, a soccer match or a cricket match, you may have viewers from around the globe. So you may have millions of viewers across the globe who are watching that match. The way it works generally is there's one server from where one origin where it streams from, or where it originates from. If everybody is going to that source, it will not only slow down the process, it might even bring down your server side infrastructure, and it might just choke the complete bandwidth available there. So instead of serving it from one location, what you do with content delivery is you deliver the content closer to the users. So you will have caches. There'll be one origin server and there'll be caches across the globe. So whenever a user requests for the content, it goes to the nearest possible location. Let's say I'm viewing the match which is happening in Europe from India. I wouldn't go to the server directly to the Europe. I would go to a local cache, maybe in Mumbai or maybe in Chennai, and from there it gets streamed to me, right? So it's a local location for me. It's a closer location. Also, it is distributed, so it's a content delivery network. And a lot of companies which serve content at scale use CloudFront, and again this works well with S3 as well. So those are the storage services. Let's talk about the database services provided by AWS. The first being the RDS. RDS stands for Managed Relational Database Service. And what kind of relational databases you can avail? These are managed databases. So instead of you running the servers, instead of you installing, managing, maintaining, taking backups, talking about fault tolerance and recovery, and also replication, all of that is managed by AWS for you. And what you get is you just request for a database, you get a database, you start connecting to it and using it directly. AWS has a backend service which actually manages it by itself. If that server goes down, it will also be brought back up using the fault tolerance that this RDS offers. And what kind of database that you can manage? It could be MySQL, it could be Oracle database. It supports Postgres. It has its own version of MySQL called as Aurora. It also has a SQL server. So you can provision any of these servers in a managed environment, and AWS will take over the management for you. You just use it, you can scale it, and when you're done, you can just throw it away. The second service is related to NoSQL. So relational database is what we looked at, which is RDS. AWS also offers you NoSQL service in the form of DynamoDB. There are two services actually. There's one called as SimpleDB. There is another called as DynamoDB. DynamoDB is similar to using Mongo or using Cassandra or similar kind of key value NoSQL databases. And this does scale well in comparison with RDS, right? Because with RDS relational databases, we're talking about ACID, the transactional database, whereas in certain cases you don't need that transactional feature, and you can achieve this is generally used in a lot of e-commerce or a lot of internet companies. For example, even the Facebook uses NoSQL databases to store all the user data, all the posts. Now it's not transactional, meaning if you post something on Facebook, your friends, if they receive it after an hour or after a few hours, it doesn't matter a lot, right? In comparison with a bank transaction where it has to be immediately reflected in your account, right? That's a transactional database. For transactional, we use RDS or relational databases. For non-transactional data, where you need scaling more than the transactional activities, you may want to use DynamoDB or similar services. The third service from AWS is ElastiCache. This is in-memory caching service, and there are applications such as Memcache or Redis which do that. So what ElastiCache offers is a managed instances of Memcache or Redis. Also, it is scalable and it is managed completely by AWS, right? So for database related services, you have 3 RDS, DynamoDB, and Elasticache. In addition to these services, AWS also has a Redshift, which is a data warehousing service. Let's now look at some of the networking services that AWS offers you. Now, AWS, one of the good things that it does is lets you create your own private cloud on the public cloud. What that means is you can actually create VPCs or virtual private clouds. And what happens with virtual private clouds is it gives you a perimeter security. It lets you define your own networking. You can create your own network. You can split it into subnets, and that becomes your own virtual private cloud, and you can restrict the access to that cloud from outside, so it becomes a secure service. And earlier VPC was optional, but from 2009 onwards, VPC has become default. So even if you have not created a VPC, if you just launch an EC2 instance, by default it gets launched and created inside a VPC. And with VPC you can define or have an additional security firewall at the subnet level. You can define your own routing. You can create external facing interfaces versus internal services which are not available outside at all. It can let you partition your network. It can let you restrict the access and give you an appearance of your own private network. And you can in fact connect from your office network to this VPC seamlessly, and that happens through something called as a direct connect. Direct connect is a service which allows you to connect from your office network, from your own router, to the AWS VPC endpoint. Apart from that, related to network, you also have a couple more services. One of that is Route 53. Route 53 is a managed DNS service. You can host your domain name entries. You can actually have it created automatically, programmatically. You can add AWS resources and connect them from outside world using host names, and all of that can be defined using Route 53. And you can also define some of the routes, meaning based on the available set of region, you can send the routes or send the traffic to a particular region, particular geographical region, and so on. So you can do all of that with Route 53. This is a managed DNS service. AWS also gives you some of those tools for administration and security, and a lot of these tools are free of cost. And if you talk about administrative tools, one of that is directory service, which allows you to connect with your own Active Directory or LDAP services and let you manage the authorization right from there. IAM stands for Identity and Access Management, and this allows you to create users on AWS portal. It also allows you to create users and groups and roles which can be used by the application or the programs to get a specific access to a specific resource in AWS. In AWS, everything is a resource, and every resource has a ARN, that is the identifier of that resource, and based on those identifiers you can define the access control using IAM policies. You also have a trusted advisor who which scans your network, and there is also a additional service by AWS where they'll consult you and they'll help you optimize things. They'll help you with scan and find out any vulnerabilities or network issues you have, security issues rather, and based on that they'll give you some advice. CloudTrail is good for auditing, so it keeps track of every single request, every API call, every activity which is done on the AWS portal or through API, and that is good for auditing and compliance, and to keep track of who's connecting from where and what kind of activities are being done. That's the audit trail. AWS Config is another service which will let you export all the data, all the configurations that you have, and analyze it. And based on that, you can sort of make decisions, and in terms of resource optimization and so on. Another useful service from AWS, which gives you some basic monitoring for free, and the rest of the detailed metrics are paid. But this is useful to monitor things across the AWS environment. That includes your EC2 instances, RDS, and load balancers, and every single request going to the load balancer, for example, can be tracked. You can monitor various parameters about your EC2 instance or RDS instance, and so on. So you can get a lot of data. You can also create your own custom metrics, and based on these metrics, you can also define your how do you want to scale your infrastructure if you want to. That's CloudWatch. Next, we're going to talk about deployment services. In the previous section, we talked about the various services that AWS offers and the category of services that it has. Now, in this section, we will start talking about how do you go about setting up the environment, which includes nothing but creating an account on AWS, as well as we'll talk about the sample application that we're going to use as part of our training, and how do we proceed with that, and the flow that we're going to follow throughout our training. So we'll begin with create an account and then proceed from there. So we're going to begin this section by creating an account for ourselves to follow our rest of our training programs. Now, AWS has different types of pricing. So if you go to aws.amazon.com and click on this pricing, it tells you how much each service costs and what kind of pricing that AWS has, and it also changes based on the utilization and the scale. Now, talking about AWS account, there is one thing that AWS does. It gives you everything, almost everything that you that it has to try out, right? So, and at least most of the essential services are covered under this free tier, and free tier account is extremely useful if you want to get started with AWS, but you don't want to start spending money on the cloud. You just want to learn about how it works. In that case, AWS account is something that you should definitely go for, the free tier account. And this is available for the first 12 months, and it will expire after 12 months. After 12 months, if you have any instances, anything running, it will be charged after that. So make sure you know what is running, and make sure you stop it when you don't use it or when you don't need it. Now let's look at what is covered under free tier. Free tier covers EC2, 750 hours per month. Now these 750 hours are not covered. It's not like does not mean one instance running for complete month, which comes to about 720 or 750 hours. What it means is you can run one instance for 750 hours, or you can run 5 instances each for 150 hours, about 10 days each, right? So if you can run one instance for the complete month, you can run 3 instances for 10 days, or you can run 10 instances for 3 days. It generally translates that way. So if you just want to try out everything but at scale and then give it up, you can use the free tier. You can launch multiple instances but shut it down before your 750 hours expire. Apart from that, you have many other utilities, including RDS. Again, is RDS similar to that, say 750 hours. S3 is available for up to 5 GB for free. AWS Lambda 1 million requests. That's great. And there are a few other services which are also available free, and you can actually look at what is free, how much is the quota, and based on that you can consume it. So if you really want to host something, even the live application, you can completely do that out of this AWS free tier, provided that you stick with the instance type that is supported, because it will not support a large instance. It will be the a small instance, or even what we call as T2 micro instance is what you need to limit yourself to. So do understand what type of instance is available, and based on that you choose your infrastructure, how you provision it and how do you use it. So let's go ahead and create a free account. How do you do that? Again, is you go to aws.amazon.com. You can obviously create it from here as well, but you can also go to pricing and the free tier. read about the free tier, the utilization, the limits, and what is covered in it. And when you're ready, click on create a free account. Now what you need to create an account is a credit or a debit card, and obviously a phone number which can be verified. And this is where you can create your account name, you can define your email address, password, and proceed. Now, once you create an account, there are a few things that you would have to do in addition. That is, one is setting up the payment method. This would include adding your either a debit card or a credit card, verifying that, and you also need to verify your identity by providing your phone number, and AWS will give you a call. You'll have to enter the PIN number provided, and only after that the account will be activated. Now, once you log in, if you don't see this screen, if you see a screen talking about the credit card or identity, you'll have to go back and verify your identity, provide the correct payment method. The payment method will be verified as well. And once that is done, you'll see this being activated. And this is an active account. In the previous lesson, we've created a free tier account. Now let's take a tour of this account by logging into it, and let's explore it a bit. The console that AWS offers. Now, if you want to log in, you have to go to aws.amazon.com and click on My Account, which will take you to this AWS Management Console. Alternately, you can also go to console.aws.amazon.com. You can actually bookmark this page as well. And there, you have to provide your username unless you have previously logged in and it's active, and the password. Now this is a single factor authentication. Later on, we're gonna set up a two-factor authentication as well. Now once you log in, you might see if you have already logged in and visited certain services, you'll see those services in the recent services. You'll see some solutions here. You can look at Explore AWS, and there are various sections that you can start exploring. You can also use this drop-down menu to get the list of services that you could use by selecting those from this menu. You also have resource groups, so you can create your own resource groups, and you can also add the bookmarks for the most common services that you would use. For example, we're gonna use EC2 a lot, so we'll add it here. S3, RDS, VPC as well, yeah. And you can choose the style here, so icon and text or just icons. I'm gonna pick just icons because I'm sort of familiar now with these services, and this will save some space. Now on the top right corner, this is important, you will see the region that you're part of. Now based on your account, this may not always be the Northern Virginia. You might be logged into a different region altogether as well, maybe a US West or a US East or something like that, right? Now you can also switch the region by selecting from this drop down menu. Let's say you want to host your infrastructure in Singapore, in Asia Pacific region. You can switch to that region. You'll get a completely different view. It might have a completely different set of instances, for example, running than the region in US East. So in total, I would believe this will contain about 14 regions. Two additional regions, one is China, second is US Gulf, is restricted regions. It's only for the specific users who have exclusive access to those. And from these services, you can switch or click on any of this service. It will take you to the dashboard for that. Let's explore a few of those. Like this is EC2, and it shows you, since we have just created this account, there are no instances running, nothing else created. And on the left hand side, you'll see all these options related to EC2, including what kind of instances you might want to create, the AMIs, volume, security groups, key pairs, load balancers, and so on, right? If you click on any of these, right now it contains none. Later on, once we start creating the instances, those instances will start appearing here. And you can switch to any of the services either from the drop down menu, or you can directly go and click from here. You can also create a resource group and customize the look and feel of this console that we have here. You also get an access to the organization, the billing details. All of that can be accessed from here. The concept of organizations is, let's say you have one parent account, one organization with multiple accounts. You can add all of these to one organization. That way you can track and manage the billing from one single parent account for all the sub accounts that you may have. You also see this billing dashboard, which will show you all the information, including the historical billing, the payment methods. Those are your payment cards generally added. The history of the payment. Consolidated billing is now part of the organization, and that's what it says. You can set your budgets, you can set alerts, billing alerts, you can have cost allocation tags. So there are multiple things that you can do from this billing dashboard. And if you click on My Account, this shows you the account information. So who owns this account, what is the contact information, any tax information that you may want to add. For example, India now has a GST tax, and all of that can be added from here. You can also close your account from the same page. So that's My Account. We looked at My Organization, the billing dashboard, and security credentials is another important aspect of your account. Here we are going to look at IAM again later, but just to give you an idea here, you can actually, it takes you to the IAM page, and you can define your multi-factor authentication, the passwords, access keys, secret keys for the root account, and so on and so forth. So, which is quite important as well. So that's a quick tour of your AWS console. In this lesson, we're going to cover the key concepts related to IAM, that is Identity and Access Management Service from AWS. Now, IAM is an essential service, especially from the security perspective, because it allows us to create multiple users, define the role-based access. We can also integrate this with LDAP and whatnot. And it's not only for the users, the human users, but it's also for the applications to provide access to other entities, is where IAM is essential. Now, we'll talk about a few of the essential concepts such as resources, roles, users, the policies, the multi-factor authentication that is covered as part of IAM. Now, every resource, every component of AWS, every entity which is managed and provisioned by AWS has ARN. ARN stands for Amazon Resource Name, and this is useful because when you want to provide an access to a particular resource or a service, let's say EC2 service, and a particular type of access to EC2, let's say creating an instance and or just read-only access where you can observe everything but not make any changes. So those kind of policies can be set using the ARN, and ARN can be mapped to a particular policy. Users are typically the human users who log in to the AWS account either using the browser or who use some program, either a script or it could be an application using which they could connect with the AWS services or make some API calls as well. Now, users have logins, users have passwords, as well as users have keys, and keys are actually used. There are two keys. One is the secret key, and second is the access key. Now, a combination of these keys is required for that user to make the API calls or programmatically talk to the AWS and get things done. And based on the users, you can also define policies as to which users have access to what entities, which services, and so on, right? So that's the mapping between the resources and the users who consume those. And it's a good idea to have a multi-factor authentication enabled, and you can use MFA token services. You can use either a software or a hardware token to generate the generate the token, the code every time you want to log in, right? And this is especially useful for the root accounts. So root accounts should definitely be secured with the MFA token to have that additional factor in authentication. Now, users can be combined into roles, and generally the policies are assigned by the roles or groups. Users have groups, and groups is what we use for defining the policies. Let's say admin users and the developers, and different categories of users will have different groups for those. That's for the humans. Now, a lot of times you may also want to provide access to a particular application from another application, or to a particular service from another service. An example of that is you may want to provide an access to a S3 bucket, S3 storage from a particular EC2 instance. In which case, the traditional way has been to create a user to create the keys, access keys and secret keys, but those are vulnerable. So instead of that, what you could do is provide a role to that EC2 instance which should have an ability to access S3. So instead of creating the user and assigning those, you can define an access for a particular entity, and to have and assign it by using a IAM role. So when you create an entity, you can define IAM roles, and based on those IAM roles, it will define whether it has an access to other services or not. And this is also useful for providing access to, let's say, your vendors or to external application to use certain things in your account, AWS account. Now we're going to do some hands-on exercises where we'll create the IAM users, we'll define the roles, we'll look at the policies, as well as we'll talk about the multi-factor authentication. In the previous lesson, we learnt about the key concepts related to IAM. In this lesson, we're going to explore the IAM console as well as start securing our account by enabling multi-factor authentication. Now, once you log into AWS, you can access IAM by going to the services, security and identity compliance, IAM. Again, IAM stands for Identity and Access Management. Once you log into the console, on the left-hand side, you see all the options related to managing your identities, including those of the humans, users and groups, those for the applications and AWS related entities, that is roles, and for authorization, who gets access to what, you define the policies. Apart from that, you can also integrate with your own identity providers. Now here you also see the link to log in to access your console, which we can customize later, and we can also see the current status of our account, which doesn't look so good because we have not enabled started using some of the best practices, including multi-factor authentication. We have not created any users or signed the policies, which we should do from this lesson onward. So in this lesson, we're also going to set up MFA or multi-factor authentication. Now, if you have noticed, when we log in, it would have asked you only for the password, which is not very secure, because if you lose the password, if somebody has access to your password, they can gain access to your AWS account, which can be disastrous. Now, if you want to enable multi-factor authentication, there are two ways you could do that. You could either use a hardware token or use a virtual token. The easiest and the cheapest being the virtual MFA device, which you can enable from an application running on your mobile phone. Now, if you click on the next tab, I'm going to choose virtual MFA. If you want to see the supported devices, you can also click on this. Now, this gives you a list of the MFA hardware as well as the software devices. Since we're going to enable it on our phone, I'm going to pick one of these, that is Google Authenticator. Now, let's learn how to install the Google Authenticator, and then we'll enable that multi-factor authentication from here. So I'm going to go to the Play Store on my phone, search for Google Authenticator and install. Once it is installed, I'm going to launch it and begin configuring the multi-factor authentication along with the AWS console. So I click on begin on the phone and scan barcode. And here I'm going to launch the next step. The barcode has been scanned and the account has been added, and it shows us the authentication code. The first authentication that we need to key in is this. We'll have to wait for a few seconds for the next code to appear, which has just done, and we key in this one as well to confirm and add this MFA, which has been done successfully. And if I refresh IAM console, I see the MFA being activated. How do we test it? Is by simply logging out and logging in again. So this time when we log in, it would ask us for the MFA code in addition to the password. So we go back to our application, key in the MFA code, and we are logged in. And this is how we enable the multi-factor authentication. And you should at least enable the MFA for the root account. Root account is the main account that we log in with. Later on, we are also going to create accounts for the users so that we can just lock down the root access and enable users with specific authorization to specific tasks. In this lesson, we're going to learn how to manage users and groups, or the human users that are going to interact with our system. We're also going to customize our URL that has been given to us. So if you go to the IAM dashboard and look at the sign in link, now this has some number and then signin.aws.amazon.com. So if you want to customize it with something that represents your account, you can actually create a link along those lines. So I just changed it to schoolofdevops.signin.aws.amazon.com. So any user that I create can use this link to log in to this particular account. Let's begin by creating our first user. So I'm going to create a user for myself, and that should be a user ID. So I'm going to start creating a user for myself, and that should be a user ID. I'll create another user called as DevOps. Now, if you want to provide a programmatic access, so there are two ways the user can interact with AWS. One is using this console. The console is the one we are looking at, and programmatically using the API keys, or some application, including, let's say there's a Python application, and there is a third-party application which could interact with this system using a programmatic access, where we can enable the keys. And we'll also enable the console access for these two users. So currently we're going to pick auto-generated passwords, and user should create a new password at the time of sign-in. We could also provide a custom password for that particular user. Next is about permissions, and this is where we start creating groups. Let's assume that both of these users should be part of a system administrator or a DevOps group who need to be able to manage certain entities or application operations related to our infrastructure. So we'll create a group to assign them permissions collectively, and this is where we define the policies, who has access to what, right? Now, in case of policies, there are a preset of policies that you could either choose from, or you can create your own policies, whereas it will give you an editor to create or write your policies right here. Right, so there's a policy generator. We're going to take a shortcut and provide these users certain access that is useful to start with. So when you talk about the policies, I would suggest you to use some of these. One is, if you want a user, instead of using a root user, you should always create another user and provide it an administrator access. Now, administrator access gives you almost all the capabilities, excluding some features such as managing your billing and so on, right? This is useful for the power users. The second type of access is system administration. If you just search for, let's say, admin, it gives you different types of administration. So there is a network admin, there is a system admin. Now, system administrator policy contains access to the most common services which are required, including EC2, IAM, using RDS and auto scaling and ELB, not RDS though. So you might want to pick that for specific system administrator, and then you can also add for, let's say, database administrator can have access to the RDS capabilities here. You could also update the policies later. If you want to be conservative, if you have new users, if you're not sure what access to provide to them, or if you just want to show them around and get comfortable with the account, initial developers, you can provide a read-only access. So one of the best practices is to provide read-only access for the new users, have them become comfortable with this account, and then proceed from there, and then selectively provide them access to the services that they require. So we assign a name called as DevOps to this group, and currently we're just assigning the read-only access. So 2 users, we've assigned them to a group which right now has a root read-only access. And you see the keys for those users. So there is a key pair. Actually, there's a access key. There's a secret key. Now, you should not share this secret key or make it public at all. Even here, it is generally sort of starred out. So if you want to provide them an access, you can actually send an email with the login details. Or you could go to the individual user and fetch information about those users, get the security credentials. This will allow you to manage the password. There's a link attached here. It will allow you to create the keys, disable the keys for that user. You can also invalidate an access key for a particular user. And especially if you have your secret key exposed. So what could happen is, if anybody who has an access to your access key and secret key can do whatever that particular user has access to. And then you share the details of this account with the respective users who can log in to that system. Now let's try logging in as that user. And I'm assuming the account details have been shared with the user already. Now when the user wants to log in, he or she can use the link provided. That's the custom sign-in link that we created. Use the user ID and the password provided to them. Now this tells us the account ID as well. Now once logged in, the user can do the tasks that he or she has an authorization for. For example, I could see, since this user has a read-only access, I could actually see the instances and everything else, but I wouldn't be able to make any changes. Let's try to make some changes. Let's maybe go to IAM console. And from here, let's say I try to add a user. Add it to a group. Now, when I try to create a user, it says AWS could not create user you requested because this user is not authorized to perform create user. Now that's how you control the access. So you can provide user and read-only access who can browse everything, list everything, however, cannot make changes, which is a secure way to get people started with your account and later on provide them with an access that they are authorized to do. In the previous lesson, we created a couple of users and provided them with the read-only access. Now we're going to update the policy by providing them with the administrative access so that these users can practically start creating and managing the infrastructure. Now in order to do that, we'll have to again go to the root account. So we'll switch to sign in with root account credentials. Since we have multi-factor authentication enabled, we will have to provide the MFA code. So one of the best practices is to lock down the root account and create a super user account who has an access to most of the administrative tasks, except for maybe billing and managing users and so on. So let's create such a role. We'll call it as or a group. So we're going to create a group called as admin. Now to the admin, we're going to provide the complete administrator access. Let's look at this policy. Click on the next step, create a group. Now if you want to check the policy, what this policy has an access to, you can go to the policies section, click on administrator access, and this will show you what all it has access to. It has full access to most of the AWS services. So that's our admin user. We'll also make sure that we lock down the root account. So for the root account, if you look at the account settings, we can actually set up the policies as well and apply those. These are the password policies. If you, let's say, want to mandate the password should have at least 6 characters, 1 uppercase letter, 1 number, 1 alphanumeric character. That's going to be my password policy, so apply that. So we have 2 users. One of the users is a super user who has administrative access, and then there's another user which is right now read only. We're going to provide it with the system administrator access. So anybody in DevOps should have a system administrator access anyways. So in addition to read only to all resources, we're going to attach another policy where we define sysadmin and a database admin access. And we see the policies now. We can also look at the policy and simulate it. So for example, system administrator access, let's go and simulate this policy, and this would tell us what this particular user with this policy has an authorization to do. Let's say if it's a system administrator, so this user should have access to, let's say, EC2. We go to EC2 and select actions. We'll choose one describe, create, delete, let's also go to RDS and select certain actions from here. Describe, create. Now let's run the simulations. So this user has access to all of these services. Let's add few more. Now this user does not have access to a service called as AWS Workmail. That's because it has limited access to system administrator as well as database administration policies. And that's the policy that we have set for a DevOps user. And that's how you can validate and verify whether a particular user has an access to a particular service or not using this policy simulator. Now going back here, we have already attached the policies to this user, and you can also define various aspects of that user. Let's say you want to set up the passwords, change the password, define what access it has using the policies. You can define, that's the permissions, that's part of the policies. Since we've done it for the complete group, every user in that group would have access to the same policies. That's what you see here. So there's a database administrator, read-only, and system administrator access policies set for this particular user. Now we need to add a user to this group. We have set up a group but not added any user to it. We'll have to do that. So we'll add a user rather to this group and verify from the user's permission as well. So this user has now system administrator access and is part of two different groups. And user has passwords and keys. Currently we have deactivated the key for this particular user. You can also upload the credentials for that particular user, the SSH keys and so on. Now these are something which are used for specific services like code commit though. Now that's about setting up the policies for the users. In this lesson, we're going to discuss about some of the networking essentials that are needed to understand how VPC works and configure it. We'll talk about the TCP/IP basics, some of the essential networking services, the IP addressing schemes, as well as some network utilities which could be useful for you to debug, configure, and manage the network. Now, talking about TCP/IP, that's the stack that we use that's the fundamental of the networking and the internet that we see today. And it was adopted as a military standard in 1983. And this is the standard for the communication over either the internet or even the local area network, or LANs as we call it. And the key concepts related to TCP/IP are these. So we will talk about the network addressing, class-based versus classless, that is CIDR, the network masks, the protocols, as well as the network services that are used. Now IPv4 is what we use today for addressing the devices over the internet as well as LAN as of today. There is a IPv6 which is already in making and is already being adopted by a lot of companies. However, primarily the addressing that we use right now using the dotted quad definitions is all IPv4. And with IPv4 you can assign unique IP address to a host in the dotted quadruple definition format. And with the current addressing space, we could assign up to 4.29 billion addresses. Most of those though are getting exhausted very quickly with the advent of the internet and amount of devices that we are using right now. We'll talk about the ways to actually manage the addressing effectively with the limited space right now. You will see either a numeric or a binary notation for the IP addressing, which looks like this. So on top we have a numeric notation, and on bottom we have the binary format for the same IP address, which is 192. That is 192. That's that's a binary format for 192. This is dotted quadruple definition. That's 168, 1 and 1. So generally we call it as 192.168.1. something. That's the IP addressing scheme that we use even in our LAN or local area network. Now this is a class-based IP addressing scheme, whereas we have mainly 5 classes. Class A starts from 0000 and goes on till 127.255.255.255. And then class B, class C, and D and E. Right, there are primarily 5 classes that we've been using, and every device today, including the printers, the network devices, the phones, computers, laptops, servers, even the smart TVs and whatnot, right? Each of this needs to have an IP address. Obviously, there is a limited pool of IP addresses, that is 4.29 billion, and with the amount of devices, it is quickly getting exhausted. Now, how do you manage it effectively? How do we save the world? Is there are two methods that we could use in order to manage it more effectively. One is NATing, second is the CIDR. Let's talk about NATing, right? So for NATing, we generally use, that's what we use in our private networks or the local networks. So if you are using an internet connection at home using a router, all your internal devices at home are on a private network. Typically it is 192.168 network that we typically use. And it is a non-routable network. So there are reserved blocks, reserved networks in every class. So class A has some, class B has some, class C is the most common reserve block that we use for our LAN, that is 192.168 network. And with NAT, what we do is we have a local network, and then we have a router. A router typically gets a public IP. Now this IP can either be a static IP or it could be a dynamically provided IP. Every time you reboot your router or every time you log in, it might be a different IP from a pool of IPs that the ISP or internet service provider has. Now, as the name suggests, with NAT, the router that we have does the network address translation. What that means is you would have your own local network in your own network, and whenever a device sends a traffic outside to the internet, it goes through only one IP, that is your router IP. So it does a translation. The device, the router, does a translation, and that's what a network address translation is. So to the outside world, it appears as just one IP where the traffic is originating from, and once it comes back, the packet, it gets translated back to the destination, which is a local IP. And using this mechanism, what we could do is, let's say we have an organization with 10,000 devices. We could just use one IP for the complete organization as an external interface, and then inside we can have our own private network using either of those class A, B, C reserved blocks. So it helps us save the number of IPs that we use publicly. Now let's talk about some of the issues with the class-based IP addressing. Right? It's inflexible. We are quickly exhausting anyways, and we'll talk about the CIDR, which is nothing but classless interdomain routing. And it looks like this, a classless interdomain routing. Typically, if you see a subnet net mask, that is the last bit /24, that's a CIDR format. Now let's look at the class based interface, right? So this is a CIDR format where we have a network address and the interface, the host address. And to fetch the host address, we have a subnet mask. There is a mask that we could use, that is /24. And instead of relying on only the number of IPs which are available for us with class based, we can partition it the way we would like it to be, right? So how do we define a classless interdomain address? Is by using a subnet mask, let's say /24, and that will translate to this IP address in the binary notation. And with that /24 is what we use to mask. So we use 24 once. So in total we have 4 quadruples, so 32 bits in total. So for the 24 bits we use 1, and we AND it with our IP address given, which will give us the subnet ID. And once we have the subnet ID, we can also find out the IP address or the address of that device inside that subnet. An example of classless CIDR notation is we can partition, let's say, /24 network, that is equivalent to a class 3 network, into 4/26, because we are using /24 and the /26 is what we use for subnets. So we can actually divide it into 4 subnets. That is, one starts from 0 to 63, 64 to 127, 128 to 191, 192 to 254. So each of this subnet will have 64 IPs in total. Out of those, the first and the last is reserved. One for the 0 is for the network, and let's say if it is 255, one ones is for the mask or the broadcast. Now let's talk about some of the application protocols which we typically use, that is TCP and IP, UDP, ICMP. It's essential to understand this because when we set up VPCs, we would have to set up firewalls and rules and play with IP tables or UFWs, in which case we should understand what kind of traffic it is. So let's look at some of these internet protocols, starting with TCP. Now TCP is a connection oriented protocol which gives you the guarantee of the packet being transported, right? And it waits for the acknowledgements, it establishes a connection, and TCP is a transport agent. It also does the error handling, resending of the traffic, retransmission, and it gives you sort of a guarantee of that transport. Whereas IP is a connection-less protocol, and it's basically the building block of internet. So all the traffic that travels over the internet is in the form of IP, and IP is the one which defines how the packet is formed, that's the datagram specs, how the addressing works. So that's why we call it as an IP address, and the routing across the internet and so on and so forth. That happens through the IP. So it's the TCP, which is a transport protocol, and IP, which sits on top of that transport, is what we typically commonly use, and that's why we call it as TCP IP. UDP is a connection-less protocol. It's a transport agent just like TCP. However, it's connection-less. It does not give you a guarantee of that packet transmission. So it's the application which manages the retransmissions and so on and so forth. It's not the transport. One popular example of UDP is DNS, and DNS is faster. It's UDP is faster because it does not wait for the acknowledgement and all that. So in some cases, UDP is a preferable protocol. Apart from TCP, IP, UDP, there's another one which we use typically with ping. So whenever we use a ping, it uses that ICMP protocol. It's a connection-less transport agent, and it is mainly used for control information exchange, and that's why we use ping to check whether the packets are being transmitted or not, how much of packet loss is there. So it's basically sends us or helps us to get that control information before we start exchanging packets using TCP or UDP and so on. ICMP also does flow control. It lets you find unreachable destinations. So if you when we use a trace route, if we want to debug issues with the network, we typically rely on the ICMP protocols. There's another protocol which is point-to-point, which is if you remember the modems, in the previous times, the initial years of internet, you would have to buy a modem and you would have to connect to the exchange, and that would use that PPP protocol where you would have to use a dial-up connection. It would make some noises before it actually connect, and that's the PPP if you remember. Now, talking about some common network services, it's important to understand the privileged ports, unprivileged port, what are the common services that we use. Now, the privileged ports are ranged between 1 and 1023, and you typically need a privilege or root access in order to use those, and a lot of those are reserved for specific services like FTP and SSH and DNS and so on. So these are the privileged ports, and unprivileged ports can be used or consumed by any user, any unprivileged user on the system as well. And a lot of those are used for the client side communication. Now, these are the most common privileged port examples. So if you talk about FTP runs on 20 and 21, one is the control channel, other is the data channel. Telnet uses 23, SMTP uses, that's the mail server, which uses 25. DNS uses 53, DHCP or BootP uses 67 and 68. HTTP, which is the common web service, which runs on port 80. POP3 is again a MTA, mail transfer protocol. POP3 as well as IMAP. That's on runs on 110 and 143, and then there's a SNMP, which is for network management, which is 161. Right. So now you should know about these, because when you want to establish connections between different services or open ports for particular services, AWS has a way to create firewalls using security groups, and you need to know which port to open with what protocol, whether it's TCP or UDP. If it is DNS, you'll have to open a UDP protocol, right? So you need to understand that and use it accordingly. And from that perspective, the knowledge of these services and any service that you manage on AWS is essential. Let's also talk about some of the networking utilities, starting with ifconfig. Ifconfig is extremely useful for internet interface configurations. So we generally use it for managing our network devices, and whenever you want to configure IP addresses, any properties, anything else that related to a device, let's say ETH0, ETH1 on the servers, we use ifconfig. Again, this is useful to get the configuration. Let's say you connect to a remote server. If you want to find out what is the IP address, you need to know how ifconfig is used. I'll show an example of ifconfig or these utilities. Let's say you're connected to a remote server using SSH. Ifconfig will give you the interface details for every single interface available on your system, and you can find out an IP address or details about any of that interface using ifconfig. Let's say the interface name, that is ETH0. You can also define an IP address using ifconfig command, and then it shows you broadcast, mask, and a lot of other details related to your interface. So it is generally used for interface configurations. The second utility, which is quite useful, is to query the DNS. Now, if you want to debug the DNS related issues, whether your DNS is working or not, whether your name is resolvable or not, you can use dig as a utility on a Linux or a Unix machine, and it can help you fetch entries related to any specific entry, DNS entry. Let's say dig, and you can get information about any DNS address. Right, so this gives you the A entry. You can define a network address. You can define which entry that you are looking for. Let's say I want to find out the MX entries, which are the mail server entries for a particular server. So whether your DNS has been set up or not, whether it's actually pointing to the correct IP address or not, whether you have a host name or not. So if you want to find out any of that, you can use dig. Which is a very helpful network utility. And these are the options. You can also define which name server that you would want to use using @ and a particular name server. Right, in this case, we are using a Google's own name server. You can also point to your own name server locally. Ping is a very useful utility anytime. So anytime you want to find out whether you're connected to the internet or not, you would generally use ping. And it's not just the internet connectivity. You can also find out whether you have a route to a particular server or not using ping. And ping uses ICMP protocol to give you all these details. You also can find out, so you can use this to debug networking issues. If you have a packet loss, a lot of times you'll see the connection being slow, and if you just run ping for a certain amount of time and look at the packet loss, sometimes you'll see that if you have any network issues there. Traceroute is good to get the routes, meaning if you have to connect to a particular server, and if you want to find out how many hops you have and how it is connecting, where which ISP is going through, if you have any trouble with your ISP or any of those kind of configurations, you can use Traceroute for that. You can install Traceroute or another utility called as MTR using, let's say I'm on Ubuntu, so I'm installing it using apt-get. And that shows you the every hop that is taking from your network till the destination here. And since my server is hosted in, let's say, Bangalore, India, it finally routes to that destination. So if there is any issue in between, if there is any problem with any of the network, let's say you have ISP has a problem, it will stop somewhere in between, right? And based on that, you can identify whether it's an issue inside your network or whether it's somewhere in between in one of the hops. You can also use MTR, which is a similar utility, and apart from doing the route, finding the path, it also shows you if there is a packet loss. This is actually a better version of Traceroute. It's called as My Traceroute, MTR. Another utility which is useful is Whois. This is good to find information about a particular site. Let's say you want to find who owns a particular domain. You can find that information here. You'll have to install it, obviously. So apt-get install Whois. Run a Whois query on Amazon.com, and it shows you the details with the registrar. Who owns this domain? When was it registered? That was in 1994. That's a long time ago, really. That's how old Amazon is. Right, so you can also find out who is the registrar and some of the contact details related to that site. So Whois information is quite useful to understand and to find out about information about that domain and the contact details related to that. Now those are some of the essential utilities that you should know about in order for you to configure, manage and troubleshoot some of the networking issues, which could be common when you configure VPCs and EC2 and rest of your infrastructure. In this lesson, we're going to talk about some of the key concepts related to VPC or Virtual Private Cloud. And this will include the concept of VPC itself, the subnets, routing, how do you connect to the VPC and various other concepts related to that. Now what VPC allows you to do is actually create a virtual private cloud, and that's what VPC stands for. So even though AWS is a public cloud, you can actually create your own perimeter security, your own subnet, your own firewall, your own it's almost as good as setting up your own local area network, but it's hosted on the cloud, and that's what VPC allows you to build. And then you can also segment on the same account, on the same same AWS account. You can segment your infrastructure into different networks, such as you can create a development environment versus a production environment, which could be hosted with different VPCs altogether or different subnets inside the same VPC with different routing tools. You can also restrict access to a particular environment. You can restrict access to a particular subnet from outside the outside world as well, right? So all of that can be achieved using VPCs. VPCs also give you control over your IP scheme. By default, AWS has a publicly routable IP. If you create it using the default settings, that's using the public subnet. It also has an internal IP, in addition to which, or in lieu with, you can create or define your own IP, your own subnetting, and that gives you a good amount of control over your IP addressing scheme, as well as defining the routes internally, as well as from outside to inside your network. Right, so you can define your own route tables. You can create your own route tables, and based on that, you can create really flexible and granular configuration with your infrastructure and the network. And all of this is an example of a software-defined network, because what you are doing is defining all of this through a software, or through a program, or through an application. To secure the access to cloud with VPC, you can actually set up an access from your own network to the VPC using either either a direct access, or you can set up your own VPN server to connect to the VPC from your corporate network. Now, the key concepts that we're going to talk about will include subnets, the internet gateway, elastic network interface, that is ENI, route tables, elastic IPs, security groups, and NACLs or network ACLs, and we'll talk about the connectivity as well. So let's start talking about the subnets first. So subnets allow you to partition your virtual private cloud into different sub networks, just like how we do it in our own data centers or in our office network. And you can define a range of IP addresses, and you can also create different level of isolation, meaning you can create a broadcast domain. You can segment your infrastructure into different subnets. And the isolation level that you can create could be, you can create a private network, you create a public network, or you can create a VPN only network. What that means is, in case of a public network or public subnet, any instances, any infrastructure that you have there can be exposed outside, and that's how you would have an access to a public a publicly hosted site, right? Some services though can be just internally available, or the public facing services like web servers can talk to the backend services like databases or queues, which could be hosted inside a private network. An advantage with private network is it gives you a good amount of security, and you can still have those instances access internet using a NAT interface and so on. You can also create a VPN only network where it is completely isolated and it is not available from outside except through the VPN. So you can set up a connectivity between your own corporate network or office network to the AWS VPC and access everything over that and treat it as a sort of internal network only. So VPC's IP space and subnets are defined in the form of CIDR, as we've talked about in the classless and class-based IP addressing. The VPCs are defined using CIDR, and then they are further partitioned into the subnet. So VPC has a CIDR block assigned to it, that's the network block, and then it gets partitioned into multiple networks. And a typical or default block that a VPC gets is the /16. So you can start from /16 and go down until /28 in terms of the subnets and the network size. So based on how you want to create or define your networks. And if you want to find out or define your own IP addressing, you can always refer to this IP or CIDR calculator, where let's say if you have a 10.0.0.1 address with a CIDR mask or mask bits of 16/16, that is, it'll tell you all the information about that network. So this can have maximum of 65,000 networks, and also the address is up to 65,534. This is a net mask because it's /16, so it's 255.255. Net mask is used to get the IP address, internal IP address of that host. And this is the CIDR range, which can then be further split into /24. That's a very common thing to do, or even /18/20 as per your own requirement. So that's the allowed range. So you can go from between /28 to /16. Now, if you're talking about the private network, to provide that network and access to the internet, even for the now if you're talking about the public network, we have an internet gateway to provide it two-way access. So this will not only provide an access to the internet for the instances hosted in the public network, but also allow the instances to be exposed outside. So it will allow the incoming connections too, and this is only required for the public subnet. Now when you create a VPC using the wizard, this gets created automatically, and you just need one internet gateway. This is automatically created, automatically scalable. You don't have to pay for the internet gateway. It comes by default for with the VPC. All you pay for is the bandwidth which travels through it, which is anyways chargeable. And this gets added to the custom route table by default. Again, if you create it not using a wizard, you will also have to create an internet gateway. And this is horizontally scaled, highly available and redundant, and managed by AWS itself. Now for the private networks, you won't expose those instances from outside. So nothing from outside can come into the private network. However, you may want to provide an internet access to the instances inside private network, mainly to, let's say, pull and update the packages, install packages, update those. And to achieve that, we have a concept of NAT instance. And the NAT instance provides an internet access. This is mainly for the outbound traffic, not the incoming traffic. And this is run as a separate instance in your VPC. And this is again a chargeable T2 micro instance. So if you want to provide, or if you have private networks and want to provide an internet access to it, you have to use a NAT interface, and this gets added to your route table. Next concept is related to elastic network interface. Now elastic network interface, think of it as a virtual network card, a LAN card, which can be attached to a server, to a EC2 instance, which can be detached. You can provide an additional IP to this. You can also use it in a way that you have two different interfaces, two different ENIs connected to the same server. There's also one default network interface, so you can create one more interface, put it in a different subnet as well, right? So this can be part of a different subnet as well. Now this is only available for VPC instances. There was a choice, or earlier there used to be a choice, VPC used to be a choice, but now it's not anymore. But you can also launch instances outside of VPC, in which case this is not available. And each ENI is like a network interface. It will have a MAC address. You can define a security group for it. You can create multiple private IP addresses for it. You can also attach a public IP or public address using elastic IP. Let's talk about the route tables. Now route tables allow you to provide network routes. So who can route to where? Whether you want to allow intercommunication between different subnets inside the same VPC, all of that can be defined in the route tables. And generally there is a one route table can be associated with multiple subnets, because you may have multiple private subnets or multiple public subnets, and the rules for all those public subnets will be the same. They'll use internet gateway, for example. So you can define or use the same route table or one route table on multiple subnets. However, if you have different routes, let's say different kind of configurations, public subnets versus private subnets will have their own respective route table. Now the concept of elastic IP is to provide you with a static or a constant IP. Why this is needed is because by default the EC2 takes a dynamic IP address. Now if you are using load balancer, it doesn't matter, but if you're directly connecting to the servers, to any of your EC2 instances, If you restart that instance, if you replace that instance, the IPs may change. Whereas if you require a setup where you need a constant IP address, you will have to avail the elastic IP. And it can be attached and detached to an interface. It's not attached to an instance as you may think. It is actually attached to just the interface. So you can have one server, one EC2 instance with multiple interfaces, and those can have their own elastic IPs. This can also make instance publicly routable, right? Provided that you have a route table, obviously. Now let's talk about the security features that the VPC gives you. Now there are security or the firewalls at the two levels. One is at the server level. Just like your servers too. So you can have let's say you have a data center, or you have your own office network, in which case each server can have its own firewall using IP tables or UFW or a Windows firewall as well. And then you also have an inbound firewall for your network, for your subnet. That's your entry point. That happens on your router, or you can have a secure firewall outside of router. That's for your complete office network. Similarly, you can have two firewalls. One is a security group, second is a network ACLs. Security groups operate at the instance level. That is as good as running a firewall on your own server. The only difference here is it's all software defined. It is defined independently of your server, and then you can attach a security group. Let's say you create a web server security group with port 80 open, and all your web servers will have that particular security group attached to it. Whereas network ACLs controls traffic in and out of that subnet. This is a higher level of abstraction. So you can define a network. So even if you have, let's say, security group open with port 80, but if you block it from the network ACLs, it will not be allowed, because network ACLs operate at the higher level than the security groups, and that is for the complete subnet. And the other difference between network ACLs and security groups is network ACLs or NACLs let you provide allow as well as deny rules. It's whitelist as well as blacklist, whereas security groups generally let you write only the allow rules, what is allowed. Now, in addition to network ACLs as well as security groups, you always can use IAM policies for defining the authorization. Who has access to what parts of your VPC or what parts of your infrastructure, and what kind of access it is. So all of that can be done at the IAM level. Let's look at the connectivity options to the VPC. The way you connect to the VPC from outside is there are two options. One is use a customer gateway. Customer gateway is a device on the customer side in your office or in your data center, generally a Cisco IPsec or something which supports that IPsec protocol, and which connects to the VPG or virtual private gateway, which is on the AWS side. And that's how you connect your corporate data center or your own office network to the VPC. And that is if you have the router which supports this protocol, is when you use the VPG. The other option to connect is using, or a cheaper option to connect really, is to use OpenVPN or something similar on those lines, especially for the road warrior connections where you may want to connect from anywhere in the world. You can just set up a EC2 instance or a server inside the network, inside the AWS network, which is part of the subnets which are accessible from rest of the infrastructure. And that is what you expose, or that is where you create a VPN server. And from your side, your office side, you can set up a VPN tunnel, or you can have a VPN client running on your own laptop, which can be used to gain the connectivity or access to this AWS infrastructure in a secure way. You can also do VPC peering, whereas you can take different VPCs running in the same region though and connect them together. So there are two requirements for this to happen. One is you need to have the VPCs with different subnets or different IP ranges or different CIDR range rather. You cannot have the same CIDR range with two VPCs which can be connected with each other for the obvious reasons. The second thing that you need is it should be in the same region. This cannot work across the regions. Next, we're going to look at some of the VPN scenarios and sample use cases. Now we're going to look at some of the scenarios in which VPCs can be configured. There are 4 different ways a VPC can be configured. The default configuration is with the public subnet. Let's look at the scenario 1. And this contains one public subnet. So this is a VPC with one public subnet only. And if you look at this diagram, it should explain it. So what you see here is the VPC. And inside, this is the AWS infrastructure. We have created a VPC with 10.0.0.0.16/16, and we have one public subnet. Since it is a public subnet, it would be connected with the internet gateway. And that's what you see here. How do you verify a subnet to be a public subnet? Is it should have a IGW or an internet gateway in its route table. That's how you validate, or that's how you verify whether it's a public subnet or whether it's a private. And any instance here can be exposed outside, provided that it has a public IP address or an elastic IP. So this is the simplest and the default setup, and that's our first scenario. Let's look at the scenario number 2. In the second scenario, we have one public subnet and one private subnet. So there is a region, we have a VPC, it's the same VPC, there is a public subnet. In addition to that, there is a private subnet. Now if you look at the public subnet, it has internet gateway. That's how we identify it to be public. It will also have a local route in order for the subnets to intercommunicate. The private subnet, on the other hand, only has a local route. It does not have an internet gateway. However, it could possibly, and this is optional, have an route to the NAT instance ID. That is, if you have a NAT instance. In case of NAT instance is hosted in the public subnet, and through the NAT instance, all the traffic, outgoing traffic is routed. And that's what you have in the route table for the private subnet. So this is the public subnet, this is the private subnet. None of this is available or accessible from outside. If you want to reach out to the private subnet, there are 2 options. Either through a VPN gateway, you can enter and access the servers here, or you go via the public subnet. So you may have a backend host here which you use to enter, and from there you hop on to the private subnet. That's the second scenario. Let's look at scenario number 3. In case of scenario 3, it's a VPC with public and private subnets and hardware VPN access. As I was talking about, if you want to provide an access to the private subnet, or you can set up a VPN gateway. You can also set up a VPN server, which VPN server will be something similar to the NAT instance, which will enter from here. If you have a VGW, that is VPN gateway, you can connect your corporate network using a customer gateway which connects to the VGW, and this is a secure encrypted line, encrypted channel through which all the traffic is routed. Now this does not have a NAT instance, so it will not route from the public subnet. If it has to access internet, it has to go via your corporate network. So this traffic originating from this will appear as coming out of your corporate network, and that's how this works. And from the corporate network, these instances are available as just on the local LAN or local network. The final scenario has only the VPN network. Now this is something you would use if you do not have any public infrastructure. You just want to use cloud as an extension to your own network, your own corporate network, or your own data center, in which case you provision a private VPN only subnet. What is a VPN only subnet? A subnet which has a route table which points to just the VGW. There is a local route. Local route is essential, but apart from that, any traffic that needs to flow has to go via the VGW, that is virtual private gateway, which also means it is going to go to the private network. So this is just an extension to the existing network. So these are four different scenarios with which you could configure the VPCs. First was the public network, second was public and private network, third was public private with VPN gateway, and the fourth was VPN only network. In this lesson, we're going to create a VPC using a wizard. Now, VPC that we're going to create, this is the scenario that we have taken for the WordPress application, where this is going to be a WordPress server. This is going to be the database. Database is part of a private subnet. The WordPress server, the web server, is a front end, so it should be part of our public subnet. So we are going to create a VPC with one public subnet and one private subnet. There are two ways to create the VPC. We'll actually start exploring the VPC console, and then we'll start talking about how do we use the wizard to create the VPC. Now, to choose VPC, you go to Network and Content Delivery, click on VPC, and you will go to the VPC dashboard. Here you can examine the existing VPCs, which is the default one. So even if you're not using a VPC already, or you have not chosen any, it is already available. So whichever instances or entities that you create are by default part of this particular virtual private cloud with this subnet. And you can explore the subnets, route tables, internet gateways, elastic IPs, and so on. So this time we are going to use the wizard to launch the VPC. So you go to VPC dashboard. You can start the wizard from here, not from here. Here you will manually create one. Here wizard will give you 4 options to automatically choose what scenario that you want to select based on the ones we discussed earlier. This is with the public subnet, this is with public and private, this is public, private and VPN access, and this is VPN only. Now, even though we want to create one public and one private subnet, we are not going to choose the second option. For the reason being, this option creates a public subnet, a private subnet, and a NAT instance. Now, when it launches the NAT instance, it is also chargeable. So we don't want that NAT instance to be running all the time while we are doing the exercises, because we are going to launch multiple EC2 instances again as well. So we're not going to choose that. We'll create public subnet, and then we'll create a private subnet after we set this up. Now, why wizard is useful is because it will create everything which is needed, including internet gateways, route tables, etc., along with your subnets. So that's the reason wizard is the easiest way to create the VPC subnet and VPC along with the subnet. So let's select this. Choose the CIDR blocks. Now we would typically choose that /16 network, which is perfectly okay. If you want to create a unique network, you can choose or change this generally this second number, and it will create 1067. This is useful if you want to join or peer multiple VPCs together. So I would advise or recommend changing that number. Give it a name, and you have to choose the public subnet CIDR, which has to be part of this one. So what we are doing here is splitting this 65,000 IP that we get into multiple /24 subnets. So you can create up to 254 subnets with 251 IPs each. Why 251 IPs? Because by default, every subnet's first IP is the network IP, last IP is the broadcast IP. So that takes 2 out of 256, so 254 remaining. Out of those, AWS actually reserves 3 IPs, first 3 IPs for its internal purpose, internal usage. This is something unique about AWS. So you get basically, if you have 256, in total 2 raised to 8, you get 251 usable IPs. Let's pick availability zone. So we want to host our network in at least two different AZs or availability zones, I'm going to pick 1A. I'm part of Northern Virginia as a region. So make sure you're part of Northern Virginia so that you can use the same setup that I use. If you choose a different region, you might have to pick different images when we launch instances and so on. So for the consistency sake, I would recommend using Northern Virginia throughout these sessions. This is a public subnet, so we call it as pub sub training. So tr pub sub 01, because we might create multiples. Okay, so this is fine. So DNS host names is you enable that so that you get those host names set up for your public IP, not just IPs. That's it, and we're ready to create the VPC. So our VPC has been successfully created. Let's examine it. So this is the one we created, training VPC. You'll see the subnet and the IP addressing starting with, let's say, 10.67. That's the CIDR block that we have. And along with this, it should have created one public subnet. You can also filter with your VPC ID. This is our training VPC, so we just have one subnet currently available. Now, how do you know whether it's public subnet or a private subnet? I'll give you a quick guide to understand that, right? So now public subnet should be routable to internet. And if you look at the route table for the public subnet, you'll see something called as IGW. So every VPC has an internet gateway. Internet gateway allows it an access to outside world as well as the incoming access. Now, since we have used Wizard, this internet gateway also got created automatically for our VPC, and that's what has been added to the route table here. And every VPC has a default route table, which is this. Sorry, this is the default route table, which is private. By default, you'll find that the route table has only the locally routable IPs. And if you look at your private subnets, you'll generally find just that entry. That's it. If you have a NAT gateway, there'll be an additional entry. And this is the differentiator between a private subnet, which does not have internet gateway, versus public subnet, which definitely would have an internet gateway. Unless it has an internet gateway, this is not going to be a public subnet. So that's the route table that we see here. This is the default or the main route table. So any subnet that you create by default is a private subnet. You'll have to explicitly make it public by adding it to this or attaching it to this route table. So we talked about subnets, route tables, internet gateways. Along with that, you have elastic IPs which can be allocated and attached to certain instances, and NAT gateways. If you want to create one, you would launch it from here. Again, NAT gateway, when you create it, it is chargeable because it runs on EC2. So that is something you need to understand before you create. Network ACLs are the firewalls at the subnet level. This is like, a firewall for your organization, right? So you might have a firewall for your own laptop or a desktop, and there'll be some network route, firewall that you might have for your own organization as well. And that's the firewall which you see here, which allows you to create inbound rules as well as the outbound rules here. So currently all traffic is enabled for inbound as well as for outbound. And this is associated with our public subnet. That's a network ACL or NACL. Along with that, you could create the security groups as well. So currently there is a default security group for our VPC, which allows all incoming and outgoing. So if in lieu of, if you do not create any security group, this is the one which will be used by default by your instances and the databases and so on. Now, in this lesson, we ended up creating a VPC using the wizard, and we have subnets which have been created here. In the next lesson, we're gonna create additional public and private subnets. All right, so let's start talking about the key concepts related to EC2. EC2 stands for Elastic Compute Cloud. Those are the two C's. That's the two, EC2. And with EC2, you can run the virtual servers on the cloud on demand and programmatically provision those as well, right? And this was the primary service that AWS started, and this is also one of the fundamental services of the cloud computing in general. Running VMs on the cloud, it's how it started. Now the core concepts related to EC2 are going to be, we'll begin with the regions and the availability zones. We'll talk about the instances. What do you mean by an instance? What do you mean by an AMI? What is an elastic IP, ENI, something that we covered in VPC as well as talking about the storages, how the storage gets attached to the EC2 instance. That's where we talk about the elastic block store. That's Amazon EBS. We'll also talk about the instance store, the security, tags and placement groups, etc. Let's begin with the regions and availability zones. What do you mean by a region? Region is a geographically separated or isolated, a partition of AWS, and this can mean that, let's say, India can be one region, or APAC is one of the regions rather, or Europe is another region. Then in US there are multiple regions, and there's a US West, there is a US East, and each of that is considered as a region which is geographically separated. And what do you use as region as is, if you want to host your infrastructure in different geographies. Let's say I have a global service and I want to host it across the world, right? Let's say I'm YouTube, I'm running something like YouTube, which is accessed by all over the world, applications like YouTube, Facebook, in which case I might need an infrastructure or at least content delivery network available in different geographies, in which case using region makes a lot of sense. You can also use it for disaster recovery. Let's say I'm hosting something in one country or one continent, and I want to be absolutely sure my data is not lost despite any natural calamity or whatever affects that particular region or geography, in which case you can host a replica of that and keep taking backups and send it over to a completely different continent. Let's say one in South America versus one in somewhere like Singapore in Asia Pacific can be a good choice for disaster recovery services, right? So for those kind of free things, we can use regions. There are actually 16 regions available at this point of time, and two of those are reserved. One is GovCloud and one is China region. So that also tells you how fast AWS is expanding. So this slide was created about a couple of years ago, and AWS has added many regions, and they are in process of adding 6 more regions at this point of time. Availability zones are how regions are split. So each region has multiple availability zones, and each of that is a data center in itself, right? It's a separate data center. However, the availability zones are connected with high speed, low latency links, generally the physical links, right, which give you it appears as a very fast internal network that you are using, and this is created for the high availability, meaning there are less chances that both data centers in one region are affected at the same time. It might hit one data center, the downtime, maybe a network downtime, or maybe physical some situation in one particular availability zone or one particular data center may cause outage only for that particular data center. So if you want to host an application in a highly available mode, generally we use multiple availability zones in one region. For example, if you're in India, you can consider south as one region, north as another region, west is one region, and for disaster recovery you can host it in like west in Mumbai and south in Chennai, and then for highly available infrastructure, you can, let's say, inside south region you can have Hyderabad and Bangalore and Chennai as three different availability zones, which could be connected with low latency links. So you can have your infrastructure hosted in two AZs. So something that hits, let's say, Chennai, maybe there's a flood and there's a problem with the data center, infrastructure can still be available in two other availability zones, that is Hyderabad and Bangalore, right? So that's the concept of have high availability in terms of the AWS. So even though they are different data centers, they are connected with high speed links. So when do you use high HAs or high availability zones is when you want high availability, you use AZs or availability zones. When you want disaster recovery or global presence, you would use regions. That's about AZs and regions. Let's now talk about instances. Instance is the unit of deployment in EC2. This is how you create servers. This is how you host and create your instances, right? That's your virtual compute environments. So instances are nothing but a VM running on the cloud because underlying to AWS EC2 is a Zen server infrastructure. So it's nothing but a Zen server or a VM created with the Zen server, a specialized version of Zen server that AWS runs actually. But AWS gives you a way to programmatically create it through either a browser-based application or using the APIs, right? So it's nothing but a virtual compute environment which has its own virtual CPU, memory, network, disk, just like any other VM. Now there are different types of instances by, you can categorize them by types as well as by pricing. We'll look at both. If you talk about categorization by types, there are many different types of instances, including T2, which is general purpose, M is for R is for memory, C is for compute, I is for IO, D is for a direct IO, which is another, storage optimized, G is for graphical and graphics. So based on what kind of operations you're doing, you can pick and choose an instance. Starting with T series is basically, it's a general purpose, moderate baseline performance, and it gives you a burstable bandwidth. And this is suitable for low priority general purpose workloads. When you talk about free tier as well, it gives you a T2 micro instance. And that is useful for just testing and getting started with things. But if you have a CPU intensive application or memory intensive application, it is not a good choice there. Right, and that's the T series. That's the T2 micro. If you look at this, free tier enabled instance is the T2. C type instances, and the number there is a generation. So it started with C1, then C2, C3, C4. Currently, the CPU generation, which is the latest, is C4. Right, as the processors upgrade in general, they would launch a new instance with a new generation. And this is CPU optimized, which is good for batch processing, things like if you're going to do transcoding, if you have a high performance site, high traffic sites, which need a lot of processing to be done, you may want to consider the CPU optimized. D is a dense storage. It generally gives you a good sequential read write. And D type instances are good for the disk intensive operations. So there are two types of instances. One is D generation, which is this, let's say D2. It gives you dense storage and direct attached storage options. And this is good for large scale data warehouse or parallel file system operations, right? So that's D type. There's another instance which is similar. It gives you good IO performance. And this is good for, as mentioned here, less latency in terms of the IO, and where you want to do IO intensive operation like warehouses, or you're using HDFS, or you're storing logs and processing it. Those kind of operations you might want to use D or IO type of instances. Also, D is good for sequential read writes for something like warehouse, whereas I is good for random IO, and that is suitable for NoSQL or cluster or OLTP kind of environments that you may want to use. R is memory optimized. So generally you will see more memory than the CPUs in R series of instances. And this is good for relational databases, NoSQLs as well, in-memory analytics, anything that is memory intensive, including Memcache, Redis, all of these where you have in-memory caching, where R type of instances are good. R stands for RAM actually. That's the series. Apart from that, there is D. X is also a memory intensive instance. Current R series is R4. And then we have GPU type, GPU intensive. So if you are going to use 3D visualization, graphics, 3D rendering, video encoding, you may want to consider the GPU intensive or GPU optimized instances rather. And then you also have a FPGA, which is a new type of instance, which is good for financial computing, genomics, data analytics, where your field programmable gate arrays can be modified there, right? So these are the kind of instances based on the type of application that you want to run. You can pick the kind of instance. Now, this is instances by types, by application. Now there are instances categorized by pricing as well. Now by default, what you get is on-demand instance. What you mean by that is you run the instance and you pay at per hour. Now they have introduced per minute pricing as well, which is very recent. This is going to be effective from October of 2017. It's recently been announced, so it's going to be per second billing actually, with minimum usage of 1 minute. So right now, as the things stand, the on-demand is per hour. So you pay X number of cents per hour based on the type of instances. And if you look at the pricing, if you go to EC2, if you go to aws.amazon.com and pick EC2 from the products or the services, it will also tell you about the pricing. There's generally a description page which tells you what this service does. Then you will have what are the features of that service. You will have instance type, and here you can pick let's say compute optimized or a memory optimized, and it tells you the configuration as well. Let's say compute optimized instance are C4. These are the current generation instances, and then there are previous generation instances, and it tells you that this has 2 CPUs and 3.75 gigs of RAM, and it goes on till 36 cores and 60 GB of RAM. And based on the type of instance, you also pay, or that decides your pricing too. If you look at the pricing, it also depends on the number of CPUs, number of RAM. You can also see on-demand pricing here, and based on the type of instance, based on the operating system, because generally the operating system licensing costs are also included or plugged in to the hourly pricing, and based on the instances you can get the pricing, and also the regions. So which region you're part of. Let's say if you choose Singapore, it is about 0.0075 versus if you go to Northern Virginia, it's 0.0059. So based on their cost of running this infrastructure in a particular data center, right? So instance price depends on the type of instance, operating system, the region, and whether it's on demand or dedicated. Now that's the on demand hourly pricing. You can also use AWS's calculator, cost calculator, to determine the cost that you would incur based on your usage. Now that's the on-demand instance. There's another type of instance which is quite interesting, which is called as a spot instance. Now what is a spot instance? Let's have a look. Spot instance is like a bidding process. So what happens is whenever I need any instance, AWS seems to have a lot of capacity always available to you, right? Now, since they have to maintain this excess capacity, what AWS decided to do, and that is a very interesting thing, is whenever there is a excess capacity, what they allow you to do is bid for that capacity, and you decide how much you want to pay for the spot instance, and based on that, your instance is provisioned and it is available until the spot price or the current price exceeds what you are paying, right? And what that means is, let's say you paid the current instance price is about $1, and you say that I want to pay 20 cents, and if the current price is about 10 cents, you will get an instance until the current price changes. And the current price depends on the demand. This is absolutely a demand supply thing. So if the current price exceeds, it will automatically take away your instance. So you should be ready with that, but you get instances for really, really cheap prices a lot of times. That's the spot instances. And that's an interesting story. And when you use spot instances, you'll also have to make sure that your application is resilient to the failure. You're not storing the data on that instance, because if the data is there, it might be lost. So you might want to just provision it for doing some processing when it is cheaper. Reserved instances is you'll also get a spot pricing. So if you look at the way you configure the instances, which we're gonna do later anyways, you can choose a spot instance and it shows you the current price, and it also gives you some graphs about, if you want to get an idea about what is the trend, what is the price that you should bid. You get a historical graph about that instance as well. The reserved instance is something that you reserve in advance, and good thing about reserved instances is you can get it cheaper, as low as 62% of discounts. If you choose it for, let's say, 3 years and use it actually for 3 years, right? So reserved instance is something that you reserve in advance by paying an upfront amount, and the instance is reserved for you. And once it is reserved, it is not taken away either. So sometimes what could happen as well is your instance may go down when there is a very high demand, and you may not get an instance because of the capacity issues. In case of reserved instances though, since it is reserved, you are guaranteed to get that instance no matter what. Now recently they have also created dedicated hosts, meaning if you want to host your infrastructure not in a shared in some cases like banks, there's a compliance that you cannot host your infrastructure on a shared environment, in which case AWS can give you a dedicated instance or dedicated server too, which might come at a higher cost, yes, but it's if you have a specific requirement, it can be useful as well. So that's the concept of dedicated host, and dedicated pricing is generally higher than the regular on-demand pricing. And with reserved instances, now with the new pricing, you can actually achieve discounts up to 75%. It used to be 62% at one point of time. And we discussed about the type of instances by their categories, by type, as well as by pricing. In the previous lesson, we talked about the instances by types as well as by pricing, where we discussed about on-demand, spot, reserved, and advantages with each. Now, what all you can do with instances, you can launch an instance where you create an instance. You can resize an existing instance. You can add tags. Tags are quite important because, that's how you categorize, that's how you can search for, that's how you can filter for the instances. You can define user data. User data is if you want a script to be executed automatically during the runtime, during the launch time, you can define it as a user data. You can also import and export, meaning if you have a VMware infrastructure, you can import that instance to EC2, and similarly, you can export it outside, right? You can also define placement groups. Placement groups is how they are placed. So if you want particular instances to be part of one placement group. They are generally hosted in proximity to each other if you define a placement group. And talking about network, we have discussed some of these already. Each instance has its own private IP. It can optionally get a public IP, which is generally an ephemeral IP. The public IP is what we're talking about. Private IP can remain constant especially if you are using a VPC. If you are using a VPC, you can also define your own IP addressing scheme. Elastic IP is useful if you want a constant public IP. Now, the pool of elastic IPs is limited, pool of public IPs in general is limited. So AWS is generally conservative when it assigns the elastic IP. So you should use it frugally only when you really need it. And if you need more IPs, you'll have to, you get 5 IPs by default. If you need more, you have to raise the explicit request. There has to be a justified reason for that. And only based on that case-to-case basis, AWS makes a decision whether it assigns you more elastic IPs or not. Also, what is interesting about elastic IP is if you provision an elastic IP and not use it, you get charged for that. The reason being, again, you're wasting a public resource, IP, which is sort of, which is expensive and which is limited rather, in numbers. And you can attach and detach an elastic IP freely to an instance. You can take it from one instance and attach it to another instance as well. It's independent of that instance. Elastic network interface is additional interface, as we've looked at in VPC as well. And if you want to have more interfaces to the one instance, you can create additional interfaces. Again, you can attach it and detach it to an instance. And each ENI has its own private IP, can have a second private IP as well. More than one private IPs can get a public IP. You can attach an elastic IP to an ENI. It actually does not get attached to an instance. It gets attached to a ENI or elastic network interface. Now let's talk about AMI, which is Amazon Machine Image. Now, if you're familiar with any kind of virtualization, you must be familiar with the templates. Because templates is what we use to create or to provision the instances. It could be VMs, right? Similarly, if you want to provision a server on AWS, you have to choose a template because you need an operating system. You may need some additional packages which need to be pre-installed, and that is where the templating comes in, right? So template is like a golden image. With your base operating system, sometimes your applications, any files that you need, which need to be pre-packaged, you create an image for it. That's a AMI, that's Amazon Machine Image. And using that AMI, once you have an AMI, you can provision as many servers. Let's say I want to create 100 web servers. I can just use one image with all my application pre-installed, pre-bundled, and then just go ahead and provision as many servers as I want. And in terms of AMI's lifecycle, you create or register an AMI. When you register an AMI, it becomes available. You can assign it rights. Who can use your AMI? Whether it's available only to your account, whether it is available for another additional specific account, or whether it's publicly available is something that you can decide. And you can use it, you can deregister, you can register an AMI. And AMIs are generally found here in the EC2 console. You can look at the AMIs that will have your own AMI. And when you launch an instance, you can also choose, the first thing that you choose, in fact, is the image. That could be either your AMI, that could be a community AMI, which is contributed by users such as yours. And then AWS Marketplace has its own images, which is a repository of actually vendor specific images. So if you're a vendor, if you're building an image and if you want to sell that, you can do it from the AWS Marketplace as well. Apart from that, there are few quick start AMIs provided by AWS. These are generally good choice to start with if you want a vanilla version of OS that you can trust, because these are created by AWS, and you'll find AMIs for a lot of different or most popular operating systems, including Amazon's own Linux and Ubuntu, Red Hat. There are Windows specific versions, and so on. You can also buy and sell in the marketplace. That's what we talked about. You can copy an AMI. AMI is specific to a region. So if you want to use the same AMI in a different region, you can copy it over and sync it on another region. There used to be a para-virtual. There are different types of virtualization. Some AMIs are specific to that, but right now it's mainly the hardware, virtual machines or hardware accelerated virtualization. Earlier, it used to be a different type available called as para-virtualization. This is pretty old though. In the next lesson, we're going to look at the storage options. Let's look at the storage options with EC2. Now, when you talk about the storages, it's generally the hard disk that we're talking about, which is attached to the instance. Now, how do you go about using it, or what kind of options are available? There are two options. One is instance store. Second is EBS. Now, instance store is the actual physical disk attached to that physical server or the physical VM. Now, the thing with instance store is it is ephemeral. What do you mean by that is, if you reboot that instance, if you stop that instance and start it, generally what happens when you stop an instance and start it, it might start on a different hardware. That's how AWS is designed, or EC2 is designed. Now what happens in that case is, if you start it on a different hardware, it will not have that same hard disk. So the data will be gone, absolutely gone, right? So that way it is absolutely ephemeral. And it is, however, fast because it's local disk. So if you talk about the disk read-write operations, it's generally faster than a network storage. But it is ephemeral. So if you have an application which does not store data, or if you're pushing the data somewhere else, if you're just using it for processing, using an ephemeral drive can be good option. In fact, you cannot stop an instance when you started with the root. If your root is hosted on instance store, you can only terminate that instance. Whereas if you want a persistent store, if you want the data either on your root partition or any mounted partition that you have needs to persist despite your stop and start of that instance and so on, you may want to consider the EBS volumes. EBS stands for Elastic Block Storage. Think of it as a network disk like NFS attached or mounted on your server. And since it is a network disk, it is independent of your server life cycle, and it can persist despite, even if you terminate the instance, if you had attached it from somewhere, it can persist and it can be attached and detached to any instance after that, right? So that way EBS gives you a persistent storage, but it's not as fast in performance as the instance store, unless you're using some specialized EBS drives like with a particular IO operation guarantee. Now, talking about EBS types, there are three types which are available. First is magnetic. Magnetic is like our previous generation hard disks, which had magnetic drives, which are slower in performance. Then the most common thing to use is general purpose SSDs. These are the SSDs which a decent amount of IO performance. However, this is burstable. If you want the IO guarantee that you need guaranteed X number of like 3000 IO operations per second, you can choose it that way using provisioned IOPS. Now, provisioned IOPS comes at a price, so it is expensive. Sometimes it can cost you more than the type of instance as well if you are using a smaller instance with a higher provisioned IOPS, right? So you may want to choose it carefully based on your requirements. The most common thing to use is by default is using general purpose SSDs. And that's about the storage. Now, talking about security, for security we have firewalls generally on a server. So on the instance itself we can have a firewall. Apart from that, AWS gives you a logical entity called as security groups, which again can be attached and detached to a particular instances, and these allow you to create a firewall rules such as which ports are blocked, which ports are allowed. And apart from that, for authentication we have private and public keys, the SSH key pair. So it's generally the RSA key pair that you create, and that's what you use for authenticating to the instances. Even in case of Windows, you use the key pair, but you use the key pair to decrypt the password for the administrator user that is generated automatically. And the key pairs can be attached to an instance while launching it. Talking about security groups, they are similar to firewalls as we talked about, and you can have inbound as well as outbound traffic, which you can control and attach to the instances. And those were the core concepts related to EC2. In the previous section, we have created the VPC with 4 subnets, 2 of which are public, 2 are private. Now in our public subnet, we're going to launch our public facing service, that is the web server, which will run the WordPress application, which is based on a LAMP stack. Now this is where we host our web server first, and later on we'll also create a high available setup where we'll launch it in a different availability zone as well. Now let's explore the EC2 console and learn how to launch our instance. So once you go to the dashboard, you select EC2 from either the recently available from these icons or from the resource services compute EC2, which will take you to this dashboard. We have already explored some of these features earlier when we took a tour of AWS console and a dashboard. Now we'll launch our first instance. Before we launch our instance, we should create a couple of things. One is the security group. Second is a key pair. Key pair is to access the instance. So once you launch an instance, how do you actually access it? How do you connect to it is where key pairs are needed. And this generally requires you to create a RSA key pair used by SSH. So either you can import the existing key pair that you have, or you can generate a new one. And that's what I'm going to do here and call it as training. Also, another best practice is to add your region, because if you generate key pairs, those will be limited to one particular region. So in that case, it's good to have a region name in the key pair as well. So this tells me this is for my training account. This is the Northern Virginia region, and this is the key pair 1. You can also have region name US East 1 or something along those lines. So whatever convention you like, you can create one. Once you click on create, it will generate a public key pair which is on the AWS console, which is on the AWS side, and the private key is what you get, which is what I see here. Now it's a good idea to store this securely, because anyone who has access to this private key essentially has access to all your instances which use those keys, right? So it is important to keep it somewhere carefully locked, and also change the permission to typically read only. So I'm going to move that key pair to from downloads and make it read only for my user. Next is we create security groups. Security groups are like firewalls. Either you can use a default one or you can create new ones, and that's what we're going to do for our WordPress instances. Now with security groups, you just allow whatever is essential, including, let's say, we just allow SSH port for now, and will allow HTTP for our web server from all. You can also define your own IP. Your IP will be automatically detected, and only your network from where your current machine is, only that network will be allowed in this case. Or you can say anywhere. For now, we'll just say anywhere, because that's what we want to do. Our web server should be exposed to the outside world. SSH, you can define it for your own network as well, if you want to be very specific about that. Since I have a static IP, it makes sense. If you do not have a static IP, every time you'll have to go and enable it there. Now that we are prepared, let's go ahead and launch our first instance. Now to refer to step-by-step instructions, you can also follow the labs. That is lab 401, creating Linux instance. We have created security groups and key pairs. We'll go ahead and launch our instance. I've also defined which AMI that you would want to use in Northern Virginia to launch an instance with WordPress installed. So we go to instances, launch instance. The first step towards launching an instance is creating or choosing an AMI. AMI stands for Amazon Machine Image, as we have talked about, and this is a pre-configured, pre-installed template which contains the operating system along with possibly the applications that you may want to use. These are the default AMIs, quick start AMIs. If you want to start with a vanilla version of an operating system, you may want to pick one of these because these are good quality and maintained by AWS, and they are clean AMIs, which is very important when you choose a base AMI. You can also pick your own AMIs if you have any, or go to community AMIs and search for the ID that I've given you. You could also search by the name, let's say WordPress. Now this is the image that we're going to choose, the WordPress image by School of DevOps. And this contains WordPress application pre-installed. We'll click on next, and this is where we choose the instance type. Based on this, the capacity will be provisioned in terms of the CPUs, memories, the kind of storage, the kind of bandwidth, the kind of capacity that you get in terms of GPUs and CPUs and memory, and what kind of IO performance you desire. You would choose your instance here. Since we are using a free tier account, we'll stick to T2 Micro. Again, if you are using a free tier account, make sure you choose the instances which are free tier eligible. Otherwise, you would get charged for it. Let's go ahead and review. Actually, we'll go back and now that we have chosen T2 Micro as the instance type, let's configure the instance details. Now this is where we define how many instances that we want to launch. If you desire to launch a spot instance, you can pick the spot price and choose the type as a spot instance from here. The network, it's important to pick our own VPC and the public subnet. I'm going to pick the first public subnet, that is pubsub01. Auto assign public IP, it is it depends on the subnet settings. But if you want to be explicit, you can choose as enable. We're going to do that because we want a public IP assigned so that we can access it from outside. You can also make it as a default configuration for the subnet configuration from VPC. Now IAM role, this is useful to create, and based on this we can choose the policies attached to this particular instance. So we'll go to IAM console. This takes us to IAM console. We create a role for an AWS service. For the IAM role, currently we're going to choose none, and later on we'll talk about how to set up IAM roles and the policies related to that. Shutdown behavior, whether you want to terminate on shutdown or whether you want to stop it. It's safe to use stop here. Termination protection is if you do not want that instance to be terminated by mistake, you can enable this. If you choose this, you will have to explicitly disable it in order for you to terminate. Monitoring requires additional charges. So there is a basic monitoring that AWS gives you, which is about 3-minute data, or every 3 minutes it updates. If you want a fine-grained monitoring, or if you want a per minute monitoring, you may want to choose this. However, for this you have to pay additionally. Tenancy is by default shared, but some cases if you want a dedicated tenancy, or if you want to launch this particular instance as a dedicated host like a physical server, you may want to choose that. What is the difference between dedicated tenancy and dedicated host is this is still a shared host. This is similar to running virtual machines on one single host which is dedicated to you. On the other hand, this is like a one physical server assigned to you. We choose shared. Again, to review, number of instance 1, our VPC, public subnet. Auto assign is enabled. Shared tenancy, which is default. And we click on add storage. This is where we define if you want to add a new volume and attach to that, you can pick the kind of volume that based on provisioned IOPS, cold STD, throughput optimized, magnetic volume. Magnetic is the cheapest. Provisioned IOPS is the most expensive one. You can choose the general purpose SSD. If you choose provisioned IOPS, make sure you understand the pricing. for that. And you can choose where do you want to mount it, which hard disk you want to mount it as. I'm not going to choose any, but click on next, add tags. Now this is useful because when you sort your instances, when you programmatically want to select some instances, the tags will be useful. So we can choose, let's say, role as web server and stack as training, app as WordPress. Now this is something you can define based on how you want to separate or sort your own instances. I just added 3. It's also a good idea to add an owner so that you know who owns and who has created this instance, who manages this instance. I'll use the UID. Next is security groups. Next is choosing security group. Since we have already created one, we're gonna pick that. You also have an option to create a new one from here. And make sure when you create a security group, it belongs to this subnet or the VPC that you're creating this instance inside. And we review the security group, which looks okay. And we click on review and launch. Now from this screen, you can review the details of that you've chosen, including the instance type, security groups, the details, tags, everything. You can also modify by clicking on previous, and or you can also go and edit instance detail here. And once you're okay with everything, you click on launch. Again, if you have not created the security pair, you'll have to create one here. Since we have already done that, we'll choose this and click on launch instance. Now once you launch an instance, you can look at the view launch logs, and you can go back to the dashboard and wait for this to be launched. Right now it's in the pending state. If you look at the status checks, there are 2 status checks. One is a system status checks, second is the instance status check. Instance status checks is the health check of your instance, versus system is the underlying host that your EC2 instance has been created on. Now our instance is running, it's still initializing. You can look at the description of that instance, including the instance ID, the state, instance type. It has a public IP and the host name, the DNS. Since it belongs to VPC, it also has a private IP. This is something that you can use for internal communication between 2 different instances in the same VPC. You can validate the security groups from here. Okay, so now our instance is ready. You also see 2 out of 2 checks passed. Those are the 2 checks, system status checks as well as the instance status checks. If anything is wrong here, either it will turn yellow or red. You could also access this instance by using this URL. Since it has WordPress already pre-installed, you just have to go to the browser and access it, and you should see the WordPress configuration page. Now we're gonna come back to this later when we set up a database in order for this to connect to the DB. So in this lesson, we learned how to create an instance from scratch. Previous lesson, we've learned how to create and launch an instance. We already have an instance launched with WordPress running. Now in this lesson, we'll learn how to connect to this. Now there are 2 ways to connect to this, and this is for the Linux instance. If you have a Windows instance, you'll use RDP to connect. There's a different procedure to do that, and I'm gonna create a new video for that. Now, in order to connect to a Linux instance, you definitely need the key pair and the private key created for this key pair, which we have already downloaded and stored securely with updated permissions. Now we're going to use that to connect to this instance, and this is a public instance. If you are trying to connect to a private instance inside a private subnet, you cannot do that directly the way we are doing it here. There's a different way or different procedure of doing that. So you can either use your terminal and use this IP or the host name to connect to this instance, or you can use a browser-based terminal client. However, that only works with Firefox or Internet Explorer 9. I'm using Chrome, which does not, or which has deprecated that feature already. So I'm going to connect using the key pair that I have and to this instance. Now, which username to use depends on the image that you have launched it with. Some images have EC2-user, some images have operating system specific like Ubuntu user or CentOS user, versus some others have root user as an access that you could use. Now we are going to use a term. I'm using iTerm, and I'm going to use my key pair that I already have stored somewhere, and I'm going to try connecting using Ubuntu user. So generally, if you're not sure, you can start with, let's say, EC2-user, and if that does not work, try platform specific like Ubuntu or CentOS or root. Since this is the Ubuntu image, this allows me to connect using Ubuntu user, and I'm already connected. I see that Apache running. This AMI was an image which was pre-configured and pre-defined. So it has Apache, it has PHP, it has WordPress, which is already running. So if you want to examine the configuration, you can go to etc Apache 2, and here, let's say, sites enabled should have the configuration for the WordPress site, right? And you can, this is as good as connecting to that server, and you have admin access with Ubuntu, so you can perform any task that you would want to. It's also a good practice to change the port that SSH is running on. So instead of running it on port 22, you should run it on a non-default port for the privacy and security reasons. Now, if you are using Windows-based systems, and if you want to connect to the Linux server, you cannot use the PEM key. You will have to convert it into the Windows supported format, that is PPK. Now there is a procedure to do that, and I'm going to create a different video, and you should install PuttyGen, and then convert this PEM key into PPK, and that's what you would import with Windows and connect with this server. On Windows, I would also recommend using Konemu, which is console emulator, which allows you to run SSH or Docker or Windows terminals or command prompts or admin prompt, and gives you multi-tab Windows support and so on. So that's something I would definitely recommend if you're using Windows, to connect with the existing instance, EC2 instance that you have created using the key pair that you had generated earlier. In the previous lesson, we've created the EC2 instance and learned how to connect to it. Now, there are good chances that you would start making changes to the EC2 instance once you connected and install your applications or configure things and add things, right? Now, once you're done with that, if you want to launch an instance with the similar configurations, you may want to take a snapshot of that and convert it into an Amazon machine image, that is AMI. So let's look at some of the AMI operations. First, we'll create an AMI. To create an AMI, let's make some changes. Let's say I'm going to run apt-get update to update the cache. I'll run apt-get upgrade because this image may be slightly older, and once I upgrade, it will sort of install the new versions of the packages it already had. It will also install the security patches needed, which is always a good idea. In addition to that, let's maybe install one more application. Let's say this does not have NTP server, which is an essential utility on a Linux system. We'll install that and then convert it into an image, which is extremely simple with the AWS console. Samsung and now. Yeah, it's actively running. Now let's take a snapshot of this EC2 instance and create an image, which is as good as going to the console, go to the instance, and from the action you can go to image and click on create image. Now this is where you define the image name. Let's say training WP01 is what my image name is, WordPress with Ubuntu. So that's the description that I provided. Now if you do not want the system to be rebooted, by default it will reboot the system while taking a snapshot, which is always a good idea. But let's say if you have a live application, you may not want to do that, in which case you may want to choose no reboot. It will also show you what volumes it has. We'll keep it as default and click on create image, and that's it. Once you submit the request, it will get restarted, so it might take few minutes for the AMI to be available. You can go to the AMI tab and wait for this image to be available. So if you check it after a few minutes, you will see the AMI created and available. Now you can also make this AMI available to larger public by changing the permissions. So if you look at the modify image permissions, if you want to give us access to a specific AWS account, you could add it here, or if you want to make it public, you can just save it as public here. And anybody who uses, or if you have a description of the AMI, they can search by that or the AMI ID always. You could also copy this AMI to a different region. Let's say you want to launch instances in different regions, let's say Frankfurt as well as the Northern Virginia. You could just choose the region and define the description here, and then just click on copy. It will start copying and it will be done within few minutes as well. So those are the AMI operations that you generally perform. And when you do not want this AMI, you don't delete it, you deregister it. Once you deregister the AMI, it is actually deleted and removed from your account as well. And what you pay for the AMI is for the storage. So if you're using a volume, it takes a snapshot. If you're using the root volume, it will be stored inside the S3. So the volumes or the data is stored on the S3, and you get charged for that storage. And those are the AMI operations in brief. Now, those of you who have been managing databases or have acted as in the role of database administrators would know how much of involvement and efforts it is required to configure, install, optimize, manage a database server. And a lot of cases, once you scale, you also need to scale your database up either vertically, or you might have to set up a replication and scale it horizontally, right? Now all of this needs a lot of involvement from a database administrator. AWS solves this problem by giving you all of this as a managed package, whereas all the activities, including installation of this of the actual database application, to patching, to replication, to scaling, to backups, to failover, fault tolerance, all of that is completely taken care by AWS. Let's now look at some of the key concepts related to RDS from AWS. Now RDS, as we talked about, is a managed relational database service, which is scalable and resizable as well. So you can scale both vertically by increasing or resizing the instance. You can also set up replication to create read replicas, whereas you can scale horizontally as well. And what you get as a managed service is the database environment. You can you can set up the replication, which is managed by AWS itself. Now replication itself is a challenging thing to manage, and you have to monitor it constantly, and you have to reset up replication if in case of issues. So that management is taken care by AWS for us, apart from backups, patching, recovery of the databases. And in terms of high availability, RDS supports or leverages AWS's geographically spread instances and infrastructure, where you can create RDS with multi-AZ setup, where it is hosted in 2 different availability zones. And that is quite useful because if one of the availability zone goes down, there's always another one which is ready to serve your traffic seamlessly. You can also create read replicas for the HA feature where you can scale horizontally. Now, which databases does RDS support? RDS supports MySQL, Postgres, it supports Oracle, it supports SQL Server, as well as MariaDB, which is again similar to MySQL. It's an open source fork, or it's a fork of MySQL actually. Apart from that, AWS has its own version of MySQL, optimized version of MySQL called as Aurora, which is compatible with MySQL's protocol. Now, DB instance is similar to the EC2 instance. The only difference is this works as more like a platform where it comes with everything pre-installed, pre-configured, and pre-managed. And the other difference is you don't have a control over the instance itself, meaning you cannot get a root login, root shell. You can make changes though, but that has to be done through some other concepts or other primitives. RDS uses storage which is similar to the EC2 EBS storage, and you can choose between magnetic, general purpose SSD, or provisioned IOPS based on your IO requirements, and the capacity ranges from 5 GB to 5 terabytes. Earlier, you used to have or create multiple security groups, one for databases, one for EC2. Now it is all consolidated with VPC security groups, so everything can be managed through the VPC security groups, both for RDS as well as EC2. Now this is how you make changes to the configuration of a database engine. Let's say for MySQL you want to configure buffers, caches, the number of connections. You can do that through the parameter groups, and this is an example of a parameter group for MySQL. Similar to parameter groups, you also have option groups. This is specific feature of the database engine which you can enable or disable using certain options. For example, you can enable the memcached support for MySQL by adding that as an option. The pricing of RDS depends on various parameters, that is instance class, that is whether you run a micro, medium, large, extra large, 2x large, the generation of that instance, the runtime obviously, either an hourly or a per second if that gets introduced with AWS. It also depends on the storage that we use, the capacity that you're using, as well as the type of storage that you choose, provisioned IOPS being the most expensive one. It also depends on the number of IO requests that you make per month, which is not really a significant cost though. And the backup storage, if you use backups, data transfer is always chargeable outside the AWS infrastructure. So anything which comes from internet or goes to the internet is charged. Now to set up RDS, you need VPC, you need 2 VPC subnets, because for multi-AZ setup, you have to have 2 subnets, and each subnet can be part of only one AZ. So you need 2 VPC subnets, security groups, and the RDS subnet group. Now, in terms of the best practices, managing the database as well as RDS is, to monitor for resources, to scale up in advance. You should definitely enable the automatic backups in order for you to be able to recover a failure, or, if you want to go back in time. You should also limit the number of tables. That generally goes beyond like few hundreds, but that's one of the best practices. And these are the performance metrics you may want to monitor. Now we talked about various concepts related to RDS. Now we're going to start setting up an RDS instance for our WordPress application and connect it from the application and configure the security groups and everything else which is involved. In this lesson, I'm going to give you a tour of RDS console and prepare the environment to launch our MySQL RDS. Now, once you're logged in to the AWS console, to go to RDS, we scroll to database section and click on RDS, which takes us to this console. And from here, you can launch, manage, backup, and operate the RDS databases. And RDS can come in various flavors, as we've talked about. That includes MySQL, Postgres. There is a AWS's version of MySQL called as Aurora, and this is where you can go and look at the current instances that you have running. Now, AWS has changed this console a bit, so you see this a feedback link for the RDS here. I'm gonna click cross-check this. We don't have any clusters of databases here. Performance insights are related to, this is a new feature that AWS has launched to get some performance and monitoring data out of create a dashboard for the databases, and this supports only Aurora and PostgreSQL at this point of time. Snapshots are the database snapshots. So these are like you can create like nightly snapshots or whatnot, and you can use the snapshot to restore the database at some point in time in the past. Reserved instances is similar to EC2 reserved instances. These are the ones which you buy in advance, reserve the capacity. You get cheaper price provided that you provide a commitment for a longer term. External licenses are something that you could bring in for your own databases, and this is especially useful for databases such as SQL Server and Oracle, where you may already have your own licenses. This is the BYOD, or bring your own licenses style. Subnet groups are the group of subnets. So we have to first create the subnet group before we actually launch database as well, right? And these are the subnets in which the database will be launched. And since we also would be talking about the multi-AZ RDS instances, whereas one primary instance will be in one availability zone and the second will be in AZ2 or something on those sorts, and for that you need to create a subnet group with at least 2 different subnets in 2 different availability zones. Parameter groups are where you can customize the configurations related to the databases. Since we do not have a root access or a login access to the database, the way to change the properties or the configurations is via parameter groups. Option groups are some optional properties that you could enable for your databases. These are database specific. Let's say MySQL has some memcache bindings and plugins that you could enable using option groups. Events are related to the database, so that's the sort of history of what happened or what actions were taken on that database, along with the notification. To prepare launching our first MySQL instance, we need these prerequisites. These have been given in the labs, as well as I've created this Trello board to track this. I'm going to send you a link to both. So we need a VPC which is already been created. We need 2 private subnets which are ready as well. When we did that during the VPC setup, we need a VPC security group for MySQL Server. We need to create that. Along with that, we would have to create the subnet group. Now we would be launching this database in a private subnet, so we're gonna create a subnet group with 2 private subnets. Let's go to our VPC configurations and understand how we could set it up and what we already have. We have already created a VPC called as training with the CIDR block of 10.6700. Along with that, we also have 4 subnets. Out of those, there are 2 private subnets, and these are the private subnets that we are going to use to launch our database in. Next, we need to create the security group specifically for the database. Now we already have a security group created for WordPress in the training VPC. This is the name of the VPC, and this is the WordPress security group which has inbound connection open for HTTP and SSH. Now when we create a security group for MySQL, what we need to do is provide an access only from this WordPress application. This is going to be a private subnet, and we don't have to open the port for MySQL from anywhere outside except for the web servers, and that's what we're going to enforce. So we'll use this group ID to provide or configure the access. Let's create a security group for MySQL. I'm going to name it as MySQL. Group name is also going to be MySQL, and the description. Choose the VPC, click on Yes, Create. Now select MySQL group, click on Inbound Rules, Edit, and we are going to provide access to the database application, that is MySQL, which runs on port 3306. So it is going to be MySQL/Aurora, port number 3306. That's TCP, and the source is going to be the WordPress security group, which is with this ID D52A6. This is the one. Click on Save. So we have set up an access from the web server. Our security group is ready. Next, we have to create the subnet group. We go back to RDS console, click on the subnet groups, create a subnet group for the database. We'll just call it as WP database subnet group. Select our VPC, add the subnet. Here we're going to add the private subnet and private subnet alone. We're not going to choose all, or if you choose all, you can remove selectively the public subnets. Now, how do you find out which ones are private, which ones are public? You can go to VPC, subnets, select the private subnet or search for the private subnets which have this CIDR, that's 11.0 and 12.0. So we are going to keep 11 and 12, remove rest 2. Or you can selectively add the subnets from here by choosing an availability zone, like one here and another from the second availability zone, which is this one. It is important when you create a subnet group to add two different subnets from two different availability zones. That is essential in order for multi-AZ database to work. Let's continue. And the subnet group has been created. So all of our prerequisites to create the RDS have been taken care of, and in the next lesson we are actually going to launch the RDS and learn how to connect to it. In the previous lesson we have prepared our systems to launch RDS by creating the security groups, subnet groups, and VPC and subnets were already been created. In this lesson we are actually going to launch the RDS and learn how to do so. So we are already on the RDS console here on AWS, and we click on launch DB instance. We choose the instance engine, and since we have decided to use MySQL, that's the one we're going to use. This is the open source version of MySQL database. You can also choose MariaDB, which is a fork of MySQL. Alternately, you have Amazon's own spin-off MySQL called as Aurora, and they also offer like performance and other metrics on top of that, and they claim this to be much faster. And this is compatible with MySQL, so you can actually bring in your own dumps and put it on Aurora as well. Alternately, you can pick Postgres, Oracle, and Microsoft SQL Server, in which case you should be able to bring in your own license as well. We have selected MySQL, and we're going to click on Next. If you want your database to be launched only with restriction to the free tier, you can click on Only Enable Options Eligible for RDS Free Usage Tier. That's going to be useful if you're not sure which one to pick. Now here we choose the license. Since MySQL is the open source version, it only has general public license. And you can pick the version of the MySQL engine compatible with what you already have in your own existing data center or the cloud. Now we're going to choose the DB instance class. Instance class decides how large this database instance is going to be. Since we have chosen free tier, it restricts us to use only the T2 micro. If you don't choose that, if you uncheck this option, you will see more options such as whether you want to run it with Aurora, whether you want to use multi-AZ, in which case it's going to launch 2 instances. You pay twice the amount of money. However, it would be useful in production use cases where it will automatically do the failover. To stick to free tier, I'm going to choose dev or test MySQL, which will launch a single instance. Then we come here and you can now see the options from different or various sizes based on the number of CPUs, the RAM offered, as well as the instance type, which is relevant to that. We're going to stick to T2 micro. We are not going to choose a multi-AZ deployment. You can read about multi-AZ deployment and get the information from the documentation as well. For the storage, we'll pick the general purpose SSD. If you pick IOPS, there'll be additional costs involved as well. So if you're going to use free tier, don't use that. That gives you a guaranteed performance. So storage is going to be very minimum. So we can start with, let's say, just 5 gigs, or the minimum now is 20 gigs. Earlier it used to be a 5 GB. Here you can add the instance identifier. Since it is related to our application WordPress, we're going to call it as WordPress. Provide the username if you have any specific requirements. I'm just going to pick root and the password. It has to be at least 8 characters. We click on next. You have to pick the VPC, which is going to be our training VPC here. The subnet group, there's only one, so it has defaulted to that. Whether you would want to make it publicly accessible or not, that's the choice here. We're going to pick as no because we don't want to expose it outside. We don't want to put it in a public subnet anyways. We don't need a public IP anyways, because we are going to connect to this database or access it only from the web servers. And this is a secure option, so pick no here. If you have a preference for the availability zone, you can choose that. I'm going to stick to no. Security group, you can choose to create a security group from here. Since we have already created and prepared our environment, we're going to say select existing VPC security group and choose MySQL. If you want to create the database automatically on this database server, you can choose the name here. I'm going to pick WordPress. Now do remember the username, the password, and the database that you have created, because this is the one we're going to connect to from our WordPress application. The option groups are going to be default. You can choose to have a backup retention period. This is quite useful if you want to restore your database, to a point back in time. It will keep the backups for 7 days, and this is an automatic backup. We don't have to do anything extra or any setup to do any backup or maintain those. And you can choose the number of days. I'm going to stick to 7. You can also select the window when the backup is done. So you can choose the time when you have the least amount of traffic on your system, because this might degrade your performance or make the database unavailable for a few minutes. If you want to enable the enhanced monitoring gives you a lot of data with a granularity of 1 minute at the additional costs. So you can select the granularity of even 1 second actually. That's amazing. Again, if you're using free tier, keep this disabled. You can choose whether you would want to push fixes and patches related to MySQL or minor version upgrades in an automated way. You can select the window that's a time window. Again, to recap, we have selected the VPC here, our training VPC. Public accessibility we have chosen as no. Availability zones has no preference. We have selected our VPC that we created earlier. The database name, port is going to be default, that's 3306. We'll keep it that way. Option groups are default. IAM authentication is, again, we have disabled it for now. You can choose to enable that and set up the IAM roles, which is an additional security measure. For the time being, we're going to disable this. We're going to select the backup to be 7 days. No preferences for the window, or if you have a preference, let's say 4 o'clock UTC time. This is the UTC time, so you might want to convert this into your time zone and compare the time there. I'm going to click on Launch DB Instance. Now this has started creating the instance, and if you want to learn how to connect to your database instance, you can click on this document, and this shows you how do you connect it to a specific database, let's say MySQL. Now you can use a MySQL client, which could be installed on Linux, it could be installed on even Windows, but since we are going to connect it from our web server, the best way or the recommended way to use the MySQL client or use the application which has a MySQL binding to it. You can pick your own database and choose the way or option to create that or connect to that. If you click on View DB Instance Details, these are some of the CloudWatch metrics. Since we do not have the database created yet, we don't see anything including the endpoint. Endpoint is what we would use to connect to that database. It is in creating stage now. We're gonna wait till it gets created and proceed with the configurations there. Alright, so our database instance is ready now, and it has turned to be available. Let's explore some information about it and learn how to connect to it. Now this is the monitoring console. This is integrated with CloudWatch, so we don't have to set up any additional monitoring parameters for the CPU, DB connections and so on. Since it is a managed service, it starts pulling information about the database and various parameters directly from here. And that gives you a good amount of monitoring details, including the number of connections, the queue depths, to the write and read performance, the latencies, and so on and so forth. And that's the monitoring details. We do not have the granular monitoring enabled yet, so this will get updated like every a minute or every 5 minutes or so. Here you see the instance actions where you can manage, create replicas, take snapshots, modify, and perform various other operations from there. Here you have the endpoint. Now this is important because this is what we are going to use to connect to this database from our web server and so on. So that's going to be the endpoint. And if you have a multi-AZ endpoint, the good thing about that is you only have one endpoint. even if you have like multi-master setup, and when there is a problem with the primary database, RDS or AWS will automatically fall back to the replica, or to the secondary master rather, and the endpoint will remain constant. So that way we are just connecting to this endpoint. We don't have to worry about what's running behind that and how it is being managed. These are the configurations for the MySQL. That's the Amazon resource identifier, the engine and the version, the license, when was it created, what is the DB that was created. So if you forget which DB you are going to connect to, you can come back and find out the name of that DB and the username. Password is something that obviously you have to remember, or you can reset. The option groups, parameter groups, the tags if you have provided any. The VPC security group attached to this database console, and the instance type and rest of the details can be viewed from here. Let's now learn how to connect to the database from the web server, and that's what we're going to learn about in the next lesson. In the previous lesson, we have created the RDS database with MySQL for WordPress. In this lesson, we're going to learn how to connect to the database from the web server and also configure it along with our WordPress application. Let's go to instances for RDS. Click on the instance that we created for our WordPress application. If you scroll down, you'll see the endpoint. We're going to use this endpoint along with this port in order to connect to this database. Another prerequisite for this to work is this database should allow the application or the web server or the EC2 instance that we have created to connect to this database, and that has happened, or that has been configured through the VPC. Now let's switch to EC2, connect to this EC2 instance from a terminal. If you're working on Windows, you can use PuTTY to connect to the EC2 instance. From here, we're going to use the endpoint that we have copied to talk to this RDS database. What we need in order to connect to this database is a MySQL client. If you do not have MySQL client installed, if you just type in MySQL on a Ubuntu instance, it will show you which package you need to install, which you can do using apt-get install -yq, the package name prefixed with sudo. If you run which MySQL, it shows you the version and the path where the MySQL is installed, which also verifies or validates that MySQL is ready or it's been installed. This is the client. Now, in order to connect to the MySQL server, we'll use MySQL CLI. So we're going to connect using MySQL -u root -p for asking password. You can also provide the password at this console, but it's not recommended to do that. And the host name, which is the endpoint. Press enter, provide the password. This is the same password that you chose while creating the instance, and I am successfully connected to the database. Here I can look at show databases. I see the WordPress database that I had chosen to be created while creating the RDS instance. So what I've validated is I'm able to connect to this RDS instance from my WordPress EC2 SSH terminal. Now we are also running a WordPress application which we had launched along with the AMI that we had chosen. Now if you go to the EC2 instance, pick this DNS, go to the browser, and provide that address here. It takes you to this WordPress configuration page, and we're going to click on next or let's go. And this is where we will configure the connection to this RDS database. The database name is what we have created, which is WordPress, which is okay. The username is root. Password is what you have set up. I've set up plain text password, that PASSWRD as password. This is where you will provide your password. And the connection string is again the RDS endpoint. That's the host name. We're gonna keep this as default. So database name is what we have changed. Username, password if you have defined a different password, and the connection endpoint. If we click on submit, this is going to connect from this web server to the database, and it shows me that the connection is okay. However, it is not able to write the wp config PHP file. That is because of the permission issues. Now, to solve these permission issues, what we need to do is we have to go back to our web server configuration and fix these permissions. So I'm on my web server's terminal. I log out of MySQL. This is the server that I am on, and our files are in var HTML. Now this is where the WordPress is not been able to create the files or write the files at. Now what do we set permissions to? So this is now owned by nobody and no group. We need to fix those permissions, and all these files should be owned by the user who is running the HTTPD or the PHP application. So if you look at the processes, should be owned by www data. To fix these permissions, I'm going to go back to var and run ch own -r data for the complete HTML directory, and this is going to set it recursively, so all the files inside HTML directory. So if I look at ls-l HTML, now it's all owned by www data, which is good. Now if I go back here, the alternate to do this is to use the content and create wp-config.php automatically. To fix this, I'm going to go back to the URL again, click on OK. Now this starts from the beginning, which is okay. Click on, let's go here, WordPress, username, password, connection string, submit. This time it has gone through fine, and we click on run the install. If you see this page, what it means is the web server has been successfully able to connect to the database, and it has also done additional configuration, and it is ready to be launched. So we just have to launch our site, provide the name for the site, provide a username, and this is the username and the password that you are going to use to connect to the database. For the time being, I'm just going to select this password as PASSWRD. Since it is a weak password, I'm going to confirm use of weak password from here. And here you can provide your email address. We don't want this site to be indexed automatically anyways, so we're going to discourage search engines from indexing this site. Install WordPress. Voila. That's our WordPress installed and ready. And if you want to see how the site looks like, this is the backend management console. The actual site looks like this. So if you click on visit site, That's our beautiful WordPress site. And WordPress is a great application. It is quite customizable. You can install themes. So I can quickly show you how you can change the look and feel of that site completely by adding a new theme. Right. It's not a fitness site, so we don't want that. Let's pick this one. You can preview. And install. Activate. As soon as you activate a theme, your look and feel of the site has changed to the new one. That's how easy it is to customize the WordPress site, and you can run your blogs, you can website, you can company site, you can run your some video platform. You can customize WordPress to run as various different ways. So in this lesson, we've learned how to connect to this RDS database from the web server, both via the console as well as from this web application. In the previous lessons, we have learned how to create the database, how to connect to it, and configure it along with the web server. In this lesson, we're going to learn about few additional operations that you could do on RDS, namely setting up the parameter groups, using option groups, as well as working with the snapshots. And there is a new feature that is migration. Now, if you click on this WordPress, that's the RDS instance that we've created for WordPress application. You see the monitoring details, which we've already gone through, and the configurations for that database. Now, what all you can do additionally is you can actually create the parameter groups. Parameter groups is a way to define the custom configuration for the database. For example, if you create a parameter group for MySQL, and choose a name, description, custom configurations for WordPress DB. Click on create. Now this allows you to define the properties. What properties? These are the properties or the configurations that you would typically change in the MySQL configs. And some of these examples are, I'm gonna deselect this, hide this. So these are the examples of the properties, including the logs, the default values. So what you see here are the names of the properties, the values, the current values, what are the allowed values, whether it is modifiable or not. Some of these are not, some can be modified. And then there are hundreds of properties for a database, and you are going to edit only a few of those. You can click on the next page and browse those properties as well. You can also choose or filter the parameters. Let's say, since it's a database, there are a lot of buffer configurations, or there are some caches that you could create and define the size for those caches, and you can change that, like bin log and host cache. And there are MySQL engines such as InnoDB, which has some cache information. And then if you want to change any of those, you can click on edit parameters and choose to use a different value. Let's say instead of 32,000, you can choose using 40,000. Define the query cache size to be 32,000, for example. There are allowed value ranges here as well. And I've just updated two properties. Save those changes. Alright, our parameter group has been saved. That's the WP params. Now if you want to apply this parameter group, we have to go to the instance and edit that instance to make changes. So you can either click on here and choose instance actions, or select here and choose the instance action, where you go and click on modify. Here you can make various changes to this database, including choosing the parameter group. If you want to choose the parameter group, you would have to go to database options and select the parameter group. Now, when does this get enabled? It generally gets enabled in the maintenance window, which you can choose here, and click on continue. If you want this to be applied immediately instead, you can choose that option here. Now this gives you a warning that it may cause a potential downtime. So if you're doing it in production, make sure you know what you're doing. And then we click on modify DB instance. Now that makes the changes to the parameter groups effective immediately. In a similar fashion, you can also change the option groups. However, changing the option groups is something that you would have to do rarely. Most of the times it's the configuration parameters such as bin logs, buffers, caches, and whatnot that we want to change, which generally can be achieved through parameter groups. Next, we'll talk about creating snapshots. Snapshot is the state of that database and the data at a certain point in time. And to create a snapshot, you can go to the instance, select the instance actions, and click on take snapshot. And when would you take a snapshot? Generally, let's say if you want to migrate the database before a release, you may want to preserve the that state in time before you actually start the release, so that in case you have to restore it, go back in time after making those changes, and if the changes fail, you can always restore a new database from this snapshot. I'm just gonna say snapshot, let's say release 1 WP. Click on take snapshot, and that's all we would need to do. It has started creating. It will take some time, and we'll come back after it is ready and examine this. Okay, our snapshot is ready now, and you can examine that by selecting this, and it tells you it is a snapshot of which database, what is the storage, and rest of the details here. To recover a database from this snapshot, you could select the snapshot, go to the snapshot actions, and click on restore. You can also copy that. You can share it with, let's say, other accounts. You can share it with a specific ID as well. Now, if you want to migrate a database from one account to another, you might find that option to be useful. You could also migrate the database or the snapshot to a new engine. That could be AWS Aurora or MariaDB, which are both compatible with MySQL. You can also migrate the database to a new engine, which is a feature available from the instance panel. That is selecting instance and selecting migrate latest snapshots. Is the same feature. Latest snapshot is this anyways. You can delete a snapshot. You can restore snapshot into a database by selecting this option, and this is where you can, this is going to create a new instance of the database, and this is an additional instance to the existing one that you already have. And here you can again choose all the options, something similar to creating a brand new instance. You can choose the identifier, choose the VPCs, the availability zones, the same options as earlier, and you can click on restore DB instance, which is going to launch a new instance in addition to the previous one. So in case if there is a problem, if if the DB migration has failed, you can go back in time and create a new instance and switch from your application to point to this one. That's how the DB snapshot and the recovery works. Now, instead of doing this, if you want to go back, also have the backups. And in our case, I have selected the backup of about 7 days. So you can also recover a database to a certain point in time by selecting the word database and choosing restore to point in time. Here you can choose the time, let's say just before the migration, or you can find out the latest restorable time from here, or you can choose your own schedule. Let's say I want to recover to yesterday at about 2:20 UTC plus 5:30, that is my time zone. I can choose that option and again launch a database. This also creates a new database. So those are two options. Either you can recover from the snapshot, or you can use the backups to recover to a point back in time. And those are some of the additional operations that you may want to do on your RDS database for MySQL. Now let's talk about some of the core concepts related to S3, that is Simple Storage Service by Amazon. It's a managed object storage by AWS. And S3 has been the one of the first services to be launched by AWS, and S3 has changed the way we have been using data, retrieving it. And one of the interesting examples is something that we already know about, and that is Dropbox. Now, initial versions, not now, but initial versions of Dropbox were completely hosted on S3. So imagine how awesome S3 would be, that people could actually build some solutions on top of that and sell it to the customers. Now, the way S3 works is different than the way we manage the storage, disk storage. There is a block storage and then there is a object storage. S3 is a object storage. What I mean by that is you're not going to attach the hard disks to the servers and store the data. It is an object storage where it's a scalable, reliable storage where you can store any object, any file, any data, and retrieve it when you need it. And these are the concepts that we're going to talk about. We're going to talk about buckets, objects, policies, naming, and some of the properties related to S3. As we mentioned, S3 is object-based, redundant, scalable, highly available storage on the internet. In fact, S3 gives you 11 nines of guarantee. That is 99.9999. That is 11 times, and that's just amazing. And it's a very rare situation that you would lose a data which is stored on S3 in using a standard storage class. And if you look at the features, it's definitely durable. It's very, very low cost actually, and you can store gigabits of data at in few dollars of cost, and you can actually use it for distributing that data. If you're building software, you may want to distribute it to the customer. You may want your clients to download it, in which case a lot of that software is already been hosted on S3 similarly. And it it's extremely easy to use as well. And where do you use S3 at is most of the static data. It could be static sites, it could be some media that you want to host, it could be the videos that you want to host and let people download, or it could be just the application that you want to distribute, right? You can use it for anything that you could imagine, really, right? Now, how does data get stored in S3? S3 stores the data in the form of something called as buckets. Buckets are nothing but it looks like directories or a bunch of directories for us, and buckets contain the objects. Objects are nothing but the files, or it could be subdirectories that you want to store inside that. And what buckets offer is a namespace, so that there is a global namespace that S3 shares, and every object has a unique URL that you can use to retrieve it using the HTTP calls, or you can use some API tools to make some API calls and retrieve that. And objects are nothing but the files, the data that we store. Each of that can have a version. It can actually have multiple versions, and it could also have the metadata attached with it. And every object would have its own unique object ID or the URL, which will be S3 URL. In addition to that, there'll be a bucket which is globally unique, and the object inside that. So that bucket name is globally unique. So when you create a bucket, you need to make sure that those are unique names that you create. Now, in terms of security, S3 offers ACLs, which are like permissions. You can also define IAM policies, and now S3 also starts, supporting encryption. So you can actually encrypt the data that you want to store on S3. Now, if you find S3, or if you're storing a lot of data and you still want to go cheaper than S3, you can still use reduced redundancy storage, which is nothing but every object actually in S3 is stored thrice. That's the redundancy factor of 3. However, if you want to use a cheaper service, if your data is not very, very critical, you could go with reduced redundancy storage. It is still available. However, it won't have 3 copies that the standard S3 policy is, right? But it comes at a cheaper price. You can also, S3 is region specific. So since AWS has so many regions right now, you can actually replicate the data between different regions by using S3's cross-region replication. And in terms of consistency, S3 offers eventual consistency, and that is the reason why you should never mount S3 buckets as hard disks. That is something that is strict no, because the data that you write may not be even immediately available. It is typically eventual consistent data, which uses reads after write. And some of the advanced operations that we are also going to look at are versioning, encrypting. You can actually host a complete site out of S3. That's a static site with HTML and CSS content, and that brings us to the summary. And from here onward, we're going to actually start looking at the features by actually using those. In this lesson, we're going to learn about how to create a S3 bucket, upload files to it, update the permissions, and start serving the files with S3. And that's the static content that we're going to serve with S3. To use S3 from the AWS console, we go to the storage and click on S3. The first thing that we have to do is create a bucket. The name of the bucket has to be unique as well. So we're going to choose AWS WP static as the name. Click on create bucket. It has to be a DNS compliant bucket name. We could use hyphens, so AWS static WP content is what I'm going to choose as a name, which seems to be unique. And you choose the region in which you want to create that bucket. Since all our infrastructure that we've created so far has been hosted in Northern Virginia, we're going to choose that as a region. That's the default anyways. Click on next. Now, if you want to define additional properties such as versioning, access and logging, tags, etc., you can choose it here. We're going to do that later, so we would click on next here. You can also define the permissions. Permissions are set for the current user. If you want to make the data in this bucket public, you could also define the public permissions here. So if you click on, or if you select manage public permissions, you can choose grant public read access to this bucket. It shows you the warning that everyone will be able to access this. And if you're okay with that, we would proceed to next. Now this is where you would review the configuration and click on create bucket. So if you refresh the page, you'll see that the bucket being created here. If you double click, it'll take you to the contents of that bucket. Now right now we do not have any files. You can click on properties and enable some of these. Look at the permissions. We've already set the public permissions here. I'm going to start uploading a file to it. So I click on upload. Choose a file, or you can also drag and drop here. So I'm going to choose an HTML file that I want to serve from here, which is part of our S3 modules data. Drop it here. Click on next. Now for this file, you can choose the permissions. we'll do that later. So I'll click on next right now. And you can define the storage class to be standard IA or reduced redundancy based on your requirement. If you choose reduced redundancy, for example, it will not create 3 replicas as default. It is cheaper, but you lose on high availability there. So most of the time using standard would be good. If you want to encrypt that data, if it is critical, you may want to choose the encryption options here, and you might have to define the keys before you actually use this. And we click on next and upload. This is just one way of uploading this data. There are various other applications like similar to using FTP clients, which you could use to talk to S3, upload and download the data to and from S3. This file has been uploaded here, and I get a link to this file. If I click on this link, let's see what happens. I see access denied. Why is it that? Because we have not set this file to be available for the public. The permissions on the bucket are not applicable to all the objects here. So even if you have a public bucket which people can read or list, this is not readable, or you can set up a granular access on every object as well. To make it public, you could select that object, click on more, and choose to define the permissions. You can choose various other options for this as well. So I'm going to make it public. I could have chosen the same option while uploading that file as well. And now this is public. If you try to access it, this is available. And that's our first static HTML file that we have uploaded to S3. We also looked at the permissions for the bucket as well as for the file itself. One of the interesting things that you could do with AWS S3 is host a complete static site with HTML, JavaScript content out of S3. And that's probably the cheapest way of running your website. And that too with zero management, because once you host it, you are not managing a server, you're not paying for a server, you don't have to administer it. You just have to update the content, and that gets served from the global infrastructure that the AWS has. If you don't believe it, let's see it in action. To host a site, a static site, I'm going to create a bucket. So we've already looked at creating a bucket. If you're going to host a site and provide a domain name to it, you would have to create the bucket with that domain name. Let's say I want to host a site called as AWS Training. It has to be unique. So when you add your name, maybe let's say you add your own initials and call it as .com. Select the region which we have already looked at. Click on next. Now we're going to define the properties to be publicly available. So this has to be publicly available if you want to serve the traffic over the internet. Click on next, create the bucket, and it's time to add the content. To add the content, we're going to upload from here, or we could again choose our files and drop those there. Now when you choose the files, make sure if it is a static site, you just provide, and if you're going to point to the index.html in the root, you could just take all these files along with the index.html and drop it to here. Click on next. We want to grant public read access to all these objects. So we select it right away. Click on next and review. Click on upload. It'll take some time for all these files to be ready. Once all these files are uploaded, we can browse the properties, and here you find an option which says static website hosting, which is currently disabled. Select that and select use this bucket to host a website. The index document in our case is index.html. That's the default, which we're going to pick. We do not have an error page, so we keep that empty. Click on save. This has been enabled now. If you look at the permissions, we've already added the permissions for everyone to read or list the objects. It's not a write access, it's just a read access. So for a static website, that's just perfectly okay. Now that we have created the static site, it's time to test. How do you get the URL to access this site is you go to the properties, static website hosting, and this is where you would get that URL which you could load in your browser. And that's our super fantastic AWS training site. And this site is completely built with HTML and JavaScript with CSS3. So imagine you can actually host your site for really cheap, and this is you don't have to even worry about the uptime, because this would be because this comes with Amazon's reliable S3 based infrastructure. We have started using S3 buckets. We have also hosted our static site completely out of S3, which is awesome. Let's look at some additional properties that S3 supports, and we're gonna go and do a deep dive on one of those. So if you click on this properties tab, what you see here is versioning, server access logging, static website hosting, which we have already looked at. Let's look at what each of this means. So if you want to store different versions of the same file to track the changes over time, you can enable this versioning. And once you enable the versioning, any updates that you make will create a new version of the file. So there'll be 2 copies of that file saved, or if you add another update, it will be 3 copies. This is to set up the loggings at the access request, right? So for every API access that that you make or any user makes, will be recorded and stored with server access logging, the object level logging, and so on. Now, if you want to encrypt the object for the security purpose, you can enable the encryption. You'll have to set up the encryption keys, and every object that is stored in S3 is automatically then encrypted. Tags are useful if you want to track the bills. For example, if you want to manage how much you're paying for a particular static data that you have hosted and serving out of S3, you can use a tag for that. Transfer acceleration is quite useful if you want to transfer a lot of data, huge amount of data to S3, or if you have consumers of your data, or the data is being uploaded from various places across the globe, you could possibly use this transfer acceleration. Events is quite useful to integrate S3 with some other additional AWS services. For example, an object or a file is added to a particular bucket or a directory. You may want to trigger a job, let's say a Lambda job, which will consume that object, pick up that object, and do some processing on top of that. Let's say you want to upload the videos to a bucket, and every video needs to be transcoded into certain formats. You can set that in an automated way by using these events. Requester pays is an interesting option. So a lot of companies use S3 serving their installers or static data, or whatever objects that you want to distribute to your customers. Now, most of the time, it's the it's the company which hosts the data is the one which pays for the bandwidth, the transfer charges as well. Now, if you want the requester or the consumer of that data to pay for the transfer charges, that's the bandwidth charges, you can enable this, and this is generally done programmatically because it needs a particular header to be set whenever there is a request for an object. That's the requester pays. Now we are going to use one of this property, and that's versioning. Let's enable the versioning on our bucket and see how this works. And the versions would be tracked once you enable this option. So from this moment onward, any object that you add to this bucket is version tracked. For example, we have this index.html, which is what you see here. Now, if I update a new version of that, you see the version information here. There's only one version right now. Let's upload a file. I'm going to upload a different index.html and see what happens here. So I'm going to pick another copy of index.html here, upload, click on next. All right, so now I see the latest version and the previous version. Let's find out if we are still able to upload, access that site. It's denied because the new version is not public. I'll make it public from these options. Go back, refresh. Yeah, that's another version. That's a completely different site or a page. So what I have are two different versions of that same page. Now, in versions, we can easily go back in time. Now, this is the latest version. That's what we uploaded, and that showed us the new page. Now, if you don't want that, you can either delete it, or you can also retrieve the previous version, download it manually, and so on. Let's say we want to go back to the previous version. You could just delete the latest from here, and now we have the original version of that site back. So in this lesson, we looked at some of these properties and we started using versioning. In this lesson, we're going to look at some of the management activities related to S3, and we're going to learn how to integrate S3 with the archiving service, that is Glacier. So we already created the buckets, worked with the objects, hosted the static file, enabled the versioning, looked at the properties. Now it's time to integrate with Glacier. Now if you go to S3, pick a bucket, look at the management tab, you see multiple options here. Now this is a new version of the dashboard. Earlier version had different properties, and you would see the properties generally in the right section. Now this is where we define the integration with Glacier and other lifecycle rules. You can also define the replication. Replication is cross region, meaning if you want to host a data in, let's say, Northern Virginia, but if you want to replicate that data to another region, it could be, let's say, a Singapore region or a European region, for whatever purpose. It could be for disaster recovery, or it could be to serve that data from multiple places. You could set up a cross-region replication as well. Analytics is an automatic way of getting insights into the patterns and the data usage, and based on that, it could suggest some lifecycle rules, and this is a paid feature. Metrics give you, in general, the data about your storage, requests, data transfer, and so on. And inventory is a way to export the list of objects that you have into a CSV file. Now, we're going to set up a lifecycle rule so that S3 objects can be archived to Glacier. Now, as we know, Glacier is a service for archival. It's much cheaper. It's 1/3 the price of S3. S3 itself is cheap, and Glacier is even cheaper. And we use Glacier for storing generally the archived objects, the data that we don't need very often. And how do we integrate with S3 is by adding a lifecycle rule where you can define archive to Glacier every 30 days. Or every 3 months, and you could choose the objects by using the filters. That's the rule name. If you click on next, you can use like whichever versions you want to choose. So I'm going to pick all the versions of the data since we have versioning enabled, and this is where you configure the expiration. So you can choose, let's say you want to expire the previous objects after X number of days. That's one way of archiving, or just deleting those objects. Those once they're expired, they get deleted, and that's generally the expiration rules. So what you choose here is permanently delete the previous versions of the objects. Now we're going to do a quick test by archiving or setting up the lifecycle rules to archive the objects to the Glacier. Now, since we want to do a quick test and see it in action, we'll set up an archival rule for 1 day. Now, you will have to at least wait for 1 day to see this in action, and we'll do this on the first bucket that we created here. I'm going to upload a few more objects to it. Now we'll set up a rule which archives all these objects to Glacier after a day. The minimum is at least 1 day. Archive to Glacier. Click on next. Select all the versions, that's fine. And here you're going to choose the transition. This is how you integrate with Glacier. So you're going to transition to Amazon Glacier after 1 day. Same here, the transition to Glacier after 1 day. We also want to expire those objects. So let's say if we forget to delete this, or if we don't need it after a few days, we can set up the expiry to be, let's say, after 35 days from object creation. And it is going to permanently delete all the versions. And this has been applied to the whole bucket. You can also choose a specific part of the bucket by providing the tags or the prefixes. Now we'll come back in a day and see if this has been archived. How do you know whether it's been archived in Glacier or not? Is by looking at the storage class. Right now it's the standard storage class. This is going to change to something else, which we'll look at after a day. Now if I come back and look at the same bucket after a day or so, I see that the storage class has been changed to Glacier. And if I try to access this, it won't allow me to do that because this is in Glacier. You will have to make a request in order for that file to be available, and only then you should be able to download that. And if I click on, let's say, download, let's see what happens. It doesn't allow me. So what I need to do in order for this to be downloaded is initiate a restore. So click on this. You can define the retrieval path. It could be, the time period that you see here, and you see the bulk retrieval, expedited retrieval, or the standard retrieval. I choose standard retrieval, and you can define the number of days your data should be accessible. Let's say I want to define it as 2 days, and click on restore. And this would take some time, and once it has been available, the storage class will again change to standard, similar to rest of the files in all the other buckets that we have here. And that's how the Glacier integration with S3 works, and that's how we archive and retrieve the data. We have learned about S3 as a service. Now let's learn how we could possibly incorporate S3 into our solution that we are setting up with our project for WordPress. So WordPress, we have already set up EC2, we have created the database with RDS. Now it's time to integrate this with S3. Now where do we leverage S3 is we might have a lot of static content on our site that we would deliver to their clients. It could contain images, it could contain some of the text data, videos, and whatnot, right? So all of this content can be offloaded to S3 using a WordPress plugin. Now WordPress is feature rich, and a good thing about WordPress is it comes with all these plugins for integrating with various services. So there is a S3 integration already available. Using this plugin, for example, WP Offload S3 Lite, we could directly integrate with WordPress so that WordPress will start copying over all this static content, and it will automatically create the URLs for it. So when you access that site, any images, any videos that are available actually are served out of S3. So let's learn how to integrate with our WordPress. We're going to use this WP Offload S3 Lite plugin. So you can either download it from here, or we could try searching from our WordPress console. This is our WordPress console. If you're not sure how to access this, you go to that EC2's URL, go to WP admin, and that takes you to this dashboard. And from here, we click on plugin. We look at install plugin. We don't find WP Offload. So let's install it. Let's click on add new. We could search for the plugins from here. It's the same plugin here. Let's install it. So I have installed and activated that plugin. Now to use this plugin, it also requires another plugin with AWS configuration. So that's the message that you see here. Let's install this as well. To configure this plugin that we installed, we need the AWS access keys. What that also means is we need to create a user and provide the access keys and secret keys, and the user needs to have an access at least to the S3. Let's switch back to AWS console. We're gonna go back to IAM and create a user. along with a group which would have access to S3. Let's do that from the users tab. I'm going to create a user called as WordPress. That's for that application. And this is important. That's the programmatic access it should have. That's the one which is going to give us the access key and the secret key. Next is permissions. To set the permissions, we could define the groups. Groups could be WordPress again, because I want to specify all the access that I need for WordPress in one group. We'll begin with Amazon S3 full access. Create a group. It says you need permissions. That's because when we created the user that we logged in as using IAM from the root user, we did not define all the permissions, meaning this user does not have permission to create another users. So we need to switch back to our root account, go to the IAM console, look at the current permissions. Now this user has administrator permissions as a system administrator, but that does not give you IAM access. Let's go back to that DevOps group and add some permissions. Add IAM full access, verify, come back to the previous user, attempt to create a group. Perfect, it worked fine this time. So we have created the user, defined the group WordPress with S3 access. Next is review. Click on create user. And that's gone absolutely fine. We need to download the access keys and secret keys. And those are the credentials that I'm going to enter here. Now it's never a good idea to expose your keys. So I'm gonna delete these keys or invalidate those and replace those immediately after this video. This plugin has been configured now. Let's go back to our WP Offload S3 Lite plugin. Look at the settings. Create a bucket, provide the name for that bucket, click on create new bucket there. Review the configurations. There are various configurations to integrate S3 with WordPress using this plugin. Once you do that, go back to S3. You should see the bucket being created, but it would be empty. In order to see the content, you'll have to upload some files. So we go to media, add a file, and if you go back and refresh, now you should see the images and the content being there, all because of this plugin that we installed. We have this plugin installed and configured. All the images, media that you should see on this site would be served out of S3, which is reliable, highly available, and could be a distributed storage using CloudFront in the front end. Let's now look at some of the key concepts related to CloudWatch, which is a monitoring service by AWS. Now, monitoring is one of the important aspects of maintaining and managing your infrastructure, because you need to get an insight into what is happening with your servers, with your databases. If there is a problem or if there is a load that you foresee, there needs to be scaling activity which needs to happen. Again, that all depends on the monitoring services, and that is where CloudWatch has a significance. Now, CloudWatch monitors all type of services and resources in AWS, and not only the infrastructure resources. It could also be used to monitor like application performance with some custom metrics. It also monitors the billing, which is another important aspect of the AWS in building that infrastructure as well. Now, CloudWatch has added the feature to monitor the logs too, so you can actually have the application's logs forwarded to the CloudWatch, and based on the logs, based on the events, you can also integrate it to send you notifications. So it integrates with the notification services. It also integrates with the scaling services such as auto scaling. So it monitors EC2, it monitors RDS, it monitors a lot of other resources, billings, logs, as well as applications through custom metrics. So you also have aggregate metrics, per instance metrics, you have namespaces generally mapped to the services, and based on these you can define your metrics, your thresholds, as well as your triggers for scale. Custom metrics are generally the application metrics that you want to monitor and send it to AWS CloudWatch. And based on that, you can look at the trends, look at the graphs, and also have integrated with the rest of the services, including notifications and triggers. Now, talking about alarms, you can generate the triggers. You can integrate it with SES. SES is a simple email service, and send a notification to to group of people who should be aware of what is happening with that particular resource. And you can also define automated actions, whereas you can launch a new instance or remove another instance based on the alarms and triggers generated. Now, for log monitoring, we generally need agents to be installed on the servers which can talk to the CloudWatch. They need to have either IAM roles or the keys configured so that it can send the data to be graphed and to be monitored. Now, apart from the CloudWatch, there is also a AWS Health Dashboard, which is of significance as well, because if there are at times if you see latency being increased or some issues with AWS, you can actually go and look at the AWS Health dashboard, which tells you about the general availability of services on the same day, and if there are any issues which are being noticed or which are being worked on, you'll find some updates about that as well. So right now everything is green, so it looks okay. Sometimes you'll see it being blue, or you might see a yellow, which is a degradation, which is not a complete downtime, and there could be red, which is a disruption. So as far as AWS's reliability is concerned, it's been really high, and that is reflected here. For weeks and weeks, you may not see any issues there. Now that's for North America. Let's look at, let's say, Europe. And this goes back in time, and we don't see any issues at all. Not even a yellow or not even an informational message. And that just tells you how reliable the AWS infrastructure has been, and that's the reason why a lot of companies are already using it. And if you look at this has increased propagation time, and this was an issue which was worked on, and they'll constantly update you live. So if you have any issues which are in progress, you'll receive updates at a regular interval. So you see an interval of about 821, 857, 938, 1014 was all resolved. And that's the general availability of services, no recent events, and that's the AWS dashboard. You can also create a personal health dashboard with your account, and that's status.aws.amazon.com. And that's about the monitoring services by AWS. Now in this lesson, I'm going to give you a tour of CloudWatch, and we're going to set up one alert that is for billing. Now to access CloudWatch, you go to services. It's a management tool. So management tool is the first one in management tool, that is CloudWatch. Once you go to the CloudWatch console, you'll see this dashboard here. Currently, we have not set up any custom dashboard or any of those sorts. So we just get a message saying that we have 117 CloudWatch metrics available in the region that we had launched our instances in. And you can set up the rules, you can set up events, you can also monitor the logs, in which case you can actually install the agent, the CloudWatch agent on your instances and send some data, which could be, let's say, how many exceptions and errors that I had in my application, or what is my current usage data, or even, okay, how much RAM do I have being consumed right now, because that is the data that is not automatically monitored by CloudWatch. Now this is where you can create your own dashboard. That could be the custom dashboard. You can set up billing alerts as well, And later on, when we go to auto scaling, we're going to use CloudWatch definitely, because we will have to monitor the data, such as what is the CPU utilization for that instance, and how much it is being consumed, and based on that we might want to create some alerts and the triggers where we would set up our auto scaling policies with. Now let's create an alert for billing. If I go to billing tab here and click on AWS billing, currently I don't have the permissions. Again, this user does not have permission to access billing data. So I switch to the root account. This is the IAM console on the root account. This is my user. It already is part of the DevOps groups. I don't want to provide access to all members in DevOps. I just want to provide access to this particular user. So I can actually go to the user and define the policies, or we can create a new group with, let's say, now the group name must be maximum 128 characters without spaces, etc. Here I'm going to choose the policy that is going to be billing, and make this particular user part of the group. So we're going to add a user to this group, and that's it. So now if I go back to my previous console, I'm logged in as a user, and we may also have to enable one more. Alright, so now I seem to have an access to the billing information as well. We will also enable administrator access to this account, that is accounts admin. So we go back to IAM console on the root user, add administrator access, come back, and if now we can get access to all the preferences for billing as well. To set up billing alerts from the dashboard, we'll scroll down to alerts and notification, click on enable, select receive billing alerts, click on manage billing alerts as well, and here this brings us back to the CloudWatch, create a billing alarm, and we could define if my billing exceeds, let's say I'm going to set an alert for $100 first. This will be depending on your usage, and then you can define your email and click on create alarm. We'll confirm the email later, because if you want to receive the alerts, you'll have to confirm it from your emails. And here you see that billing alarm. Currently it has insufficient data because it would take at least sometimes a few minutes for the data to trickle in here. Now if I come back after a few minutes, I should see that alarm being okay, and you can click and check the graph as well, which should start showing some data. This has been set to 1 week. We'll set it to, let's say, 1 hour, and there's some data which is being generated, and based on that, as per the current charges, our billing is okay. So in this lesson, we're going to learn about the use of auto scaling, as well as what are the core concepts related to auto scaling, which is one of the fascinating features of AWS. Now, why do we need auto scaling is for two reasons. One is for dynamic capacity. Now let's look at this diagram, which is actually a chart from one of the infrastructures that we manage for an e-commerce site. Now if you look at this site, if you look at the trend, general trend, this is by day. So this is 31st, 1st, 2nd, 3rd. So this is a graph of about 2 weeks. Now if you look at this pattern, what you notice is the traffic or the number of requests going down at certain point of time and going up during some part of the day. And that is generally the peak hours where most of the transactions happen, or most of the people are online and they want to use or visit this site. Whereas the lull period is generally the night times during the region or the geography where this site is hosted. Now, when you have less number of traffic, you don't have to run, let's say, for 10,000 requests, I need one server. Now, when I have 20,000 requests, I may just be good with two servers. When I have 30,000, I may need three. When I have 40,000, I may need four or five, right? So when the traffic is at the highest, you may need 4 instances, versus when it is lowest, you may need 2 instances. And this is just an example. And when it goes up suddenly, let's say there's a sale period, or there is some event which triggers the more traffic being generated, you may need to have, let's say in this case, with the calculation that we have at 70,000, we may have 7 servers, maybe one more to just manage the spike, maybe, right? So from 2 to 8, we need to scale it automatically, and that's what AWS allows you to do. AWS allows you to set up controls and triggers where, based on the traffic and based on how it grows, let's say it's 25,000 requests, you launch one more server. When it's 35,000 requests, you launch one more. So you have 4 servers even before you reach that peak period. Right, and that's the concept of AWS auto scaling. So you don't have to maintain. In this case, the maximum servers you may need are maybe 8. So you don't have to maintain those 8 servers all the time and pay for it. You can scale up and scale down whenever you need and achieve the economical advantage of that dynamic capacity. That's the example of a dynamic capacity. Now, the other reason why you may want to use auto scaling, which is less discussed, is maintaining the fleet. Let's say you need at least 2 servers of a certain type at any given point of time. And let's say there is a failure, there is a problem with one of the AWS availability zones, or there is a problem with one of the underlying hardwares that your instance is running on. It might go down in that case, and you may lose your capacity, whereas AWS will detect, if you define an auto scaling, it will detect that it has gone below the minimum number of servers, and it will automatically relaunch it. And you can use it obviously for high availability reasons and leverage AWS's multi availability zone setup infrastructure. Now, when we talk about auto scaling, we also discuss about the ELB, which is Elastic Load Balancer, because when you have more servers serving this traffic, you're not going to have requests going to different servers. You're going to have it sent to one load balancer, and from that load balancer, it gets distributed across the number of instances which are available at that given point of time. And when you have more servers, it's just matter of adding or managing that capacity or the scale using another primitive called as Auto Scaling Group. And that's the concept of ELBs. Elastic Load Balancers are elastic again. So they are automatically managed by AWS. You don't have to install, manage anything here. It scales automatically. So if you have more number of servers, this server itself or whatever infrastructure it uses can scale up accordingly, according to the number of requests. But that should happen gradually. That's the caveat there. And it is highly available, it is scalable, it is a network load balancer. Now AWS has recently introduced in the recent years application load balancers as well, which work well with a lot of application specific caches, SSL offloading, the stickiness, and a lot of other features that the application requires. Now there are a few concepts related to the auto scaling. One is the launch configuration. Now when the scaling activity happens, when there is a new server added, with what configuration it should exist, with which size you want to create that server, whether it's a large server, whether it's a small server, whether it's a T2 micro, whether it's an M3X large, you need to define all of that. You need to define the image that is used, and that is defined with launch configuration. It's the configuration that you're going to use to launch a new server. And you need to predefine and save it so that AWS can automatically decide what type of server to launch and how many to launch, and with how to scale it goes as part of the auto scaling group. Now, what you define in launch configuration is typically instance class, the AMI, the key pair to use, and a few other details. Now, who defines how many servers to launch, who maintains the capacity, is the auto scaling group. And auto scaling group defines how many numbers of instances should be there, when to launch a new one, what is the trigger, When should that happen? So all of that is defined by auto scaling group. It also defines an integration with ELB, whereas when the server is launched, it is automatically added to the load balancer. And it defines the launch configuration, which launch configurations to use, because that is integrated with auto scaling group. And the capacity, minimum, maximum, desired. Desired is what we define, and also minimum and maximum. So this is the range. So you can say that, okay, I want to scale between 2 and 20, and right now I want 5 servers. That's the desired capacity. And you can define ELB configurations, triggers, and policies with the auto scaling group. Now, having learned about these concepts, we're going to actually apply these in action. So we'll set up a high available fault tolerant WordPress infrastructure using the auto scaling configurations. After looking at the concepts, we're going to start setting up the auto scaling for our WordPress installation, which looks like this right now. We have the EC2 instances, the RDS, which is connected to, and we have also integrated it with S3 earlier. Now, in order to make this scalable, meaning let's say if we start generating more traffic, we need to be able to support that, and for that we're going to set up this auto scaling group, and our infrastructure would look like this after at the end of this. In addition to that, we'll also set up a load balancer that is going to be a ELB, and that will accept the request and spread it across the servers which are available. And the auto scaling will make sure that one is we have enough capacity available. That's the minimum capacity. Let's say if we need minimum 2 instances, we can set the minimum in the auto scaling group to be 2 and the maximum to be whatever else we want. Let's say we scale between 2 and 5. And the second thing that will ensure is as soon as the traffic goes up, we have more instances being provisioned automatically and added to the load balancer. Now the first step towards setting up the auto scaling is going to be setting up the load balancer. So let's go back to our EC2 console now. We just have one instance and we are directly connecting to that instance using the IP address. Instead of this, we are going to now set up a load balancer, and for that we scroll down to the load balancing here and click on load balancers. Create a load balancer. Now this is where you can define either you want a network load balancer that's just gonna connect to the TCP over TCP, or more intelligent HTTP or HTTPS, and this will also take care of our certification handling and various other things, right? And that's exactly what we want. So we'll click on create and select or name our load balancer to be, let's say, WordPress. This is for the application WordPress, so we'll just choose that. This is internet facing. This is not an internal load balancer. If you choose internal load balancer, it will not route the traffic from outside. We don't want that. IPv4 is just okay for now. And the load balancer port, this is the port it's going to listen to. That's okay here. If you want to add more listeners, you can have multiple listeners as well. Let's say you choose HTTP and HTTPS. You could add that as well. So we'll have to select our own VPC, and right now we just have 2 subnets in 2 availability zones, so it will allow us to select them. Since we have already tagged those, it should be easy for us to choose. So we add this and this. Next is security settings. Now this is where we generally use HTTPS. We're gonna skip to the next settings here. You can define a security group for the load balancer as well. And the only port that we want to allow is 80. So that's already been selected. You can add additional rules from here as well. And next is configure routing. Now this is where you define the backend servers. So you can just say new target group, name it as something, define the protocol, the port to listen to, and the target type is going to be instance. and we'll just choose the root path. That's absolutely fine for us. You can also do advanced health checking, where you define the healthy thresholds. Healthy thresholds is it's going to consider the instance to be healthy only after 5 checks, and it will deem it unhealthy if the health checks fail for 2 consequent times. So we need to determine that it's unhealthy immediately, but when we want to bring it back into the load balancer, we want to do that gracefully only after verifying that it is healthy for at least 5 instances. You can define interval if you want, let's say an interval of 10 seconds. That's absolutely fine as well. And the success codes are the return codes. When you make a GET request, generally it's 200, which is okay, and that's what we choose here. Let's go to the next one and register some targets, which are our existing instances. Create. And our load balancer has been created. It says provisioning, so we'll wait for it to be ready. Okay, now our load balancer is ready, and let's have a look at the configurations for the same. So here you see the name of the load balancer. That's the Amazon resource name. This is important because this is the URL or the A record that we're going to use to point to this application using the CNAME record or something similar to that. You'll find the security groups, etc. And what is important is the listener. Listener is listening on port 80, and it is going to forward the request to WordPress. This is nothing but the target group that you would see along with the load balancer. You can get the monitoring data. Once it starts getting requests, etc., this should start filling in as well. So if you come back in few hours and if your application is being consumed, or you can start a benchmarking for your application, and you'll see the data being updated here. Now if you go to the listeners, that is forwarding to WordPress, this, if you click on this, it takes you to the target groups anyways, and this is where you would see what targets, what is the configuration, and which are the currently active targets or registered targets. There are no instances in the target groups registered right now. To add some, we can in fact add our existing one. So we click on edit, and this lists our existing instances, which shows us our WordPress instance. You select it, add to the registered, and click on save. Now it says none of these availability zones contains healthy targets. Requests are being routed to all targets here. So these are the registered ones, and currently it is being initialized, or it is being added. Once the target is healthy, we could go back to our load balancer and start accessing that through the load balancer, not via instance. And here we're going to need the DNS for the load balancer. That's our site, and that is not the EC2 instance, that is the ELB URL. And if you add few more instances, it would start load balancing across those instances automatically. That's our ELB. In the previous lesson, we have created the load balancer. In this lesson, we're going to learn about how to create a launch configuration, which we would use to configure the auto scaling groups. Now, talking about auto scaling groups, even though auto scaling groups and load balancers are independent entities, a lot of times they go together. Meaning, when we want to launch new servers, for example, when we want to scale up and launch new servers, or when we want to remove some servers, what we also want to do is update the load balancer so that it starts routing or stops routing the traffic to these new servers or that we launch. And that happens during the auto scaling configuration as well. And that is the reason why we generally create it together, even though a lot of times you would also see auto scaling groups being used independent of load balancers. Now, in order for defining the auto scaling group, or when the scaling activity happens, you need to determine what configuration to launch that instance with. So what is going to be the AMI, the instance type, security groups, what key pair to use, and to define that, we have to provide some pre-configuration, and that is where the launch configurations come in. Now, to create a launch configuration, you go to auto scaling and you will click on launch configurations. And if you look at this, it doesn't say launch configuration yet, because since we have not created any auto scaling group the first time, even if you try to create a launch configuration, it's going to give you a option to use auto scaling group along with that. So let's go ahead and click on this. So the first step is to create the launch configuration. Then we define auto scaling group. In this video, we'll only create the launch configuration. So this is, if you notice, this is as good as launching a new instance. However, this is not going to launch an instance, but it's just going to take all the options from you and store it so that when the scaling activity happens, this is automatically launched. Remember, it's going to happen automatically, not a manual launch of the instance. And that's the reason we are defining all of this right now. So to launch our WordPress, we're going to pick our own AMI. So I click on my AMI, select the WordPress AMI that I had built initially or that I had used initially. Now, this does not contain the latest configuration that I've configured, but this is good enough for me to understand how autoscaling works. So I select that. Next, we select the instance type. Since I want to be free tier eligible, I'm going to pick T2 Micro. Click on the configuration details. This is where you define the auto scaling configuration, and I'm going to pick the name as WPLC01. Why 01 is because later you may want to change or update the configuration for auto scaling, in which case you will create a new launch configuration, maybe for the same auto scaling group. And in order to support that, right away we would start with the numbering, that is 01 here. We don't want to launch spot instance, so I am role, I don't have any yet. This is a good idea to enable CloudWatch detailed monitoring when you're running auto scaling. However, since it would incur additional charge and since I want you to be just free tier eligible, I'm not gonna recommend that right now. So advanced details, you may want to provide user data, IP address. We don't want to assign IP address to this server because we are using ELB, so there is no need to have an external IP address attached to that as well, right? So internal is fine. Internal is automatically assigned anyways. And then we select the storage. If you want to add any additional drives mounted, you can define it here. Security groups, we already have one, so we choose that security groups for WordPress application, which shows me port 80 and 22. Review and click on create launch configuration. It's not launch instance, it's create launch configuration. You define the key pair and click on that. That's it. That's would have created the launch configuration anyways. Now, if you want to see that without updating the auto scaling group, you can always go back here. And now you would notice that you have an option to create additional launch configurations. However, when you're creating it for the first time, you may also you may also want to go all the way and create auto scaling groups as well. That's what we would do in the next lesson. Now that we have defined the launch configurations, let's go ahead and create an auto scaling group. Now, auto scaling group, or ASG as it is called, is where we define what happens during a scaling activity and when does a scaling activity happen. And that is exactly where we define what should be the minimum number of instances that we want, what is the maximum capacity we want to scale to, and when a scaling activity happens, what configurations to use, that is the launch configuration to use and launch it. And when it is launched, how many instances to launch, what is going to be the unit of scaling, what is going to be the scaling metrics, etc, etc. Let's just go ahead and create the auto scaling group. So I'm on EC2's auto scaling group console, click on auto scaling group here, select the launch configuration that we had created earlier, provide a name for this auto scaling group. That's gonna be WPASG. Here you don't have to number it because the auto scaling groups can be updated with the configurations later, unlike launch configuration. And this is where we define, we want to start with 2 instances. Choose the VPC. Subnets have to be the public subnet since we are creating this auto scaling group for our web servers. So we choose both these subnets. This is where you define if you want to receive the traffic from the load balancer. Since we want to integrate it with load balancer, we choose that option and define the target group. Now earlier you would have to define the auto scaling load balancer here, but not anymore, because we have target groups which automatically would add it to the load balancer's configuration. Now the health check is for for the EC2 instances, whether the instance has been healthy or not, and you wouldn't want to use either the ALB health check or EC2. Most commonly the EC2 is fine. Instance protection is if you do not want this instance to scale in or be deleted when the scaling activity happens, or when the servers are decreased in size, the capacity is decreased in size, you may not want to delete this, and that's when you choose this option. Now for now we're just gonna keep the group at its initial size, which is number 2, and later on we're gonna add the scaling capacities as well. So let's go ahead and look at the notification options. Now if you want to be notified by email typically when the scaling activity happens, whether it's scaling out or scaling in, you can pick the address you want to send the notifications to, etc., and you can define that here. You can also tag or provide the tags for the auto scaling group, and then if you click on review and look at the configurations here, you can choose create auto scaling group after that, and it has been created. If you go back to the auto scaling group, this is where you see that it's been launched, and the number of instances currently are 0 because we have just created it, so it would have started launching new instances. I'm gonna open the instance console in the next tab, and I see 2 more instances being launched. Once they are ready and healthy and warmed up, it would get added to the load balancer as well. Now let's examine the auto scaling group details. So if I come back and look at this output after a couple of minutes, I see 2 instances added and ready. I also see which launch configuration is currently effective, that is LC01, the target group where the instances being launched would be added to. The desired configuration is if there is a scaling activity, generally the desired number is what would change. Let's say if CPU load goes up and we want to scale based on that, the desired will be changed to, let's say, 3 or 4 when there is an event which triggers. The health check type is here, and the availability zones that we selected, so all that information, as well as the activity history is important, because this is what would tell you what happened and when, and what was the trigger of that event. So the creating and launching of instances has been successful. We do not have any scaling policies yet. We're going to do that in the next lesson. So we'll skip to the next one. Instances is what we see here. The monitoring data for those instances will start being updated in a few minutes. We've just defined a notification as well, so that I would get, for example, notified whenever the instance is launched or a new instance gets launched during the scaling activity. We have not defined any tags yet. You could create tags similar to the EC2 instances that we did. And that's sort of a summary of how do we go about launching the auto scaling group, and the information about this after it has been created. In the previous lesson, we have created an auto scaling group with a fixed size. Now this is great to maintain that fleet, meaning if there is an instance which gets terminated or is unhealthy, it will automatically replace it. So it's good for that, but it's not very good for dynamic scalability, where you may want to scale up or create new instances automatically when there is more traffic and so on and so forth. And that's the real advantage of using auto scaling after all. So let's define some scaling policies which would allow us to dynamically scale or provision the capacity. Now, how do we determine the scaling policy? There are many metrics you could use. There are certain metrics which come by default that you could leverage. That, let's say, CloudWatch gives you CPU utilization, number of requests, 2 ELB, and so on. So we are going to use a very simple metric here, the triggers, and that's going to be CPU utilization. That's the average CPU utilization across let's say web servers. And what we want to do is, if the CPU utilization goes above 60%, we want to scale immediately. And when we scale, it's a good idea to scale it in, let's say more numbers, so that you can, if you have, especially if you have random, if random traffic or sudden spikes. So in that case, you can scale to, let's say, 2 instances at a time instead of 1. And when you scale down, that is going to be, let's say, we want to wait till the load comes down, CPU utilization comes down and goes below 40% before you take any instance out. And when you do that, you may want to scale slow. So you may want to scale it with a unit of 1, and then wait for, let's say, 5 minutes, 10 minutes, 20 minutes before you scale down. And when you scale up, it should be immediate. When you scale down, it should be slow and gradual. That's the strategy that I would typically recommend. Now let's create a scaling policy by going to the auto scaling group, go to the scaling policies tab, add a policy, give it a name. Let's give a name to this policy. We'll just call it as WP SCL out. Instead of picking the average CPU utilization, the metric type, which is automatic scaling policy that we'll add, we're gonna choose a simple scaling policy, which will give us more control. When do you scale, with what unit, etc., etc. And this is where we're gonna choose an alarm. So we could create a new alarm where we define that the average CPU utilization should cross 60%, should be equal to or greater than 60% for at least 5 consequent periods of 1 minute. Now we don't want to wait for a long time when you want to scale up, and that is the reason I'm gonna pick the period of 1 minute and 5 units or 5 intervals of that. Let's create an alarm. So let's say 60%. In addition to triggering the policy, I would also get notified with this. And this is where we define what activity we do. So whether we add, whether we remove, or whether we set the number to a specific, fixed number. So we're going to define add 2 instances. You could also choose percentage of group. Let's say if you have 10 instances which are already there, and if you define 20%, it's going to launch 2 more. And when it is 20, it's going to launch 4 more. So it will be percentage of the group. We're just gonna pick 2 instances, not the percentage. And then we'll have to wait for about a few minutes. So let's say it takes 120 seconds for the application to come up and warm up and be ready. You can choose that interval, and after that it gets added, and based on that the health of the instance is determined basically, and added to the load balancer as well. That's our policy for scaling out. Let's create it. Now, when you create the one for scaling out or create launching instances, what happens if when the load goes down? You have to define the scaling in policy as well. That's what we would do. It's not scaling up and down, it's scaling in and out. It's a horizontal scaling. So we add one more policy, that is WP SCL in. Again, we'll have to create a alarm, simple scaling policy. Choose an alarm, we'll create one. So the average CPU utilization should be less than 40%, and here we're gonna pick a longer interval, let's say 4 consequent periods of 5 minutes, so 20 minutes. So when you scale down, do that gradually. When you scale up, do that rapidly. That's the idea. So we call it as 40%, create alarm, close. And we have to define what do we do. So when you scale down, again, scale in, you do that gradually. So we won't remove both instances that we launched earlier. We would remove one instance at a time and wait for, let's say, 5 minutes before next scaling activity happens. We don't want to rapidly scale down. We want to wait for about 5 minutes before the next instance is brought down. That's our scaling in policy. Let's create it as well. So we have one policy for scaling out and one for scaling in. You can create multiple policies for scaling in and out as well. So there could be multiple situations or multiple metrics which demand scaling out or scaling in, and you can define those repeatedly here, or you could go to the CloudWatch and define the notifications from there which can trigger a scaling activity too. If you look at the instances here right now, we just have 2 instances. We have defined the scaling policies. In the next lesson, we are going to see how this scaling policy works, as well as what happens, how does auto scaling group really works, and what happens if you remove one instance, etc., etc. So let's look at that in the next lesson. We have created the auto scaling group, launch configuration, defined the scaling policies as well. Let's now see it in action, how it actually works. Now, if you look at this auto scaling group, I have the minimum instances set to 2. Let's see what would happen if you delete one of those instances. Now this has been launched with the launch configuration, and I'm going to delete it and see what would happen. So I'm just going to go to instance state, terminate. Now it's going to take a few seconds for this auto scaling group to detect that this instance is gone and unhealthy, and that is the time when it will trigger some action here. So it has detected the instance not being healthy, says terminating EC2 instance, in progress, and the scaling activity should happen shortly, meaning it should replace that with a new instance. Since it is connected to ELB, it will also drain the connections from the ELB so that it gracefully exits. And it has also launched a new instance. So if you look at the number of instances, it is 3. Desired is going to be 2. Minimum is 2. But right now 3, because it has to replace that with a new one. So the total number of instances that we see are 4. 1 that we launched manually, 1 which has been terminated, and 2 which are now running, and this is the one which has been recently launched and being initialized here. It's not in service. It will take a couple of minutes for it to start serving, be added to the load balancer, and start serving the traffic. If you go back to the load balancer and check as well, so if I go to the target groups, I see the instances, some of those are unhealthy. 1 would have been terminated. The one which has just come up probably has failed the health check, but this will come in, and because it has to wait for 5 minutes or few minutes basically to be added to the load balancer and considered as healthy. Okay, so now if you look at the scaling activity, the instance has been launched successfully, and everything looks like normal. Now let's trigger the scaling policy. Now how would you trigger a scaling policy? Obvious way to do is to have some realistic traffic when the CPU percentage goes up, and it would automatically do so. However, since we have not been running anything inside that yet, we can also simulate the scaling policy. Let's simulate a situation where the load goes above 60%, and we are going to trigger the scaling policy by executing WP scale out. Now another interesting feature that the auto scaling groups have is the scheduled actions. Now what is a scheduled action? Let's say we are running this site and we are launching a new sale, and we are expecting a lot of traffic tomorrow after, let's say, 10 o'clock when the announcement goes public. You can actually define an action where there'll be automatic scaling up activity which would happen. Instead of being based on a particular trigger, you can define an interval or a schedule saying that I want to scale up like sale, the Diwali sale, for example, or a Christmas sale. You can define it that way, and define the minimum number. Let's say I want to define it as minimum I need 5 servers, maximum can be 20, and the desired would be, let's say, 5 as well. That's the minimum. And we just want to do it let's say once, because we have the scale being launched tomorrow That's, let's say, 17th, and at UTC time would be around 4:30, and that's it. And similarly, this is one time activity, but you could also have it defined in an automated way, so that it happens every minute, every day, so at a particular time, and then you can also define it to scale down and so on and so forth. That's going to be extremely useful a lot of times. Now, if you create a scheduled activity, make sure you delete it as well, because we've just created it for testing. And if you don't delete it, it will actually go ahead and launch those many instances. So make sure you clean it up. Let's look at some of the DevOps services that AWS offers, which could be good for both developers as well as the operations folks. And these are related to infrastructure as a code, setting up the build, deploy pipelines, configuring things automatically, managing the scale, monitoring, and so on. The first of this service is the CloudFormation. Now, CloudFormation allows you to write your infrastructure as a code, where it lets you model your AWS infrastructure using templates, and then you can provision it automatically, right? And this gives you a lot of control, and what you write is in the form of JSON or a YAML specification about what you want to launch. It could be security groups, EC2 instances, RDS, S3 buckets. You define the policies, security, everything related to that. You can, sort of correlate those with each other, and it gives you a lot of control over how do you write it and define it. And this is useful for the system operations, SysOps, DevOps personnel, also for system architects who want to convert or model your infrastructure, and it lets you save a lot of time while provisioning the infrastructure. You can revision control it, so you can put it in Git repository or somewhere and share it with others, and they can use the same template for provision the same infrastructure, and gives you that repeatability as well as the granular control over what all you would want to configure. Now, this gives you the perfect control, but it also needs a lot of coding and a knowledge on the system side of things on the AWS infrastructure. Now, if you're a developer, you have a better tool than this, and that's what Elastic Beanstalk is. And this service is also a platform as a service, a PaaS service from AWS, where you can bring in your code and just deploy it immediately, and AWS will take care of building the underlying infrastructure. It's the fastest way to get your app running without bothering about how do you build your infrastructure, how do you install and configure it. Let's say I have a Node application. I need to start with creating EC2 instances, install the application, configure it, make sure it works, scale it on my own, monitor it. So all of that is taken care by the EB or Elastic Beanstalk for us. And it also scales, so you can define the scaling, how you want to scale and so on. And it does that in an automated way, right? So it's good for auto scaling, auto provisioning, like a typical 3-tier infrastructure, and it supports these languages, PHP, Java, Python, Node, .NET, Go. At the time of creating the slides, it supported these languages. And Docker, since it supports Docker, everything else can be sort of containerized and deployed using Elastic Beanstalk. This is extremely well suited for the developers who don't want to bother about the underlying infrastructure and want to get started with a scalable infrastructure on AWS immediately. There's a third solution which integrates with another infrastructure as a code tool, that is Chef. So let's say you have an architecture diagram, and it's a, let's say, 3-tier infrastructure. You can actually convert it into that 3-tiered infrastructure using a visual interface along with your Chef code. And it supports more than 3 tiers typically. You can define as many layers, so it gives you more control. It also gives you control over how do you configure that underlying environment, however, in an automated way. That's where the Chef integration comes in. So you can define for every layer or every tier, you can define which Chef recipes are to be executed. It's good for developers, operations, and even the architects who want to build that and then integrate your Chef recipes there. Now, apart from these, there are these three, like the OpsWorks, that is Elastic Beanstalk, and CloudFormation, there are certain tools which are useful for developers to build the pipelines. One of that is Code Commit. Now, Code Commit gives you a hosted, this is like GitHub but provided by AWS, right? So it's a hosted version of Git repository. So I'll take you through all of these services. One of that is Code Commit, which is nothing but a GitHub like repository hosting service by AWS. So you can actually integrate it. The good thing about these is you can integrate with every other service that AWS has. So it is well integrated with the complete ecosystem there. That's first. Second is build. So once you check in your code, what do you want to do next? You want to set up a build service, and this is again a hosted, managed build environment. And you can bring in your code, you can compile it, run test, generate the artifacts, and all of that can be done with AWS hosted repository. So you don't have to build and manage another infrastructure for this. Same with code deploy. This is a tool which helps you define your deployments, how you want to do the deployments, when do you want to do that, what is the process, and give you a control and resources inside AWS. This works outside AWS as well. So if you have any other servers, you can deploy it the same way. Think of this as a managed version of, let's say, Capistrano or service like that. There's another one which is a replacement for Jenkins or your CI integration server. So instead of hosting that CI or Jenkins yourself, you can actually do that on the cloud with AWS Code Pipeline and go from, let's say, source to build to staging to production, all with the managed service that is provided by AWS. So Code Commit, build, deploy, and pipeline are some of the useful things from the continuous integration perspective of DevOps. And apart from that, if you want to analyze your application, trace the request, this is like similar to, I would say, New Relic. If you want to see what is happening with your application, you may want to use AWS X-Ray. There's another tool which comes along with this called as CodeStar, which integrates with Jira as well, which I believe is a collaborative suite from the AWS to manage and track your work. Now, those are some of the useful services from the DevOps point of view. And we just looked at deploy, pipeline, and talking about CloudFormation, we'll discuss about how CloudFormation works in the next lesson. Let's look at how CloudFormation works. This is one of the essential services from the DevOps point of view, as we've talked about, because it allows us to create that infrastructure as a code using either JSON or YAML. And once you do that, you can revision control it. It gives you a lot of flexibility and control over what all you can configure. And if you look at a CloudFormation template, it generally has these fields. So you have description where you define, what it does, define the parameters. That's, it's a template. So template accepts the parameters. You can use the same template with different parameters to create or to define it or to, run it in a different way. Then you define some mappings like, okay, if you choose a particular instance type, which image should be used. So that is the kind of mapping that you can define. You can define any conditions if required, and resources. Resources is where you define what you want. Let's say you have EC2 or RDS or security groups or any of that. And the template, it starts with template version actually, and then you have outputs. So it starts with template version. There's only one so far, and then you have description, the parameters, the mappings, the conditions. Resources is the most important one, and that's where you add the building blocks and define the outputs that you have. Now I'm going to show you an example of a CloudFormation template, which is right here. This is the CloudFormation UI, and if you search for the CloudFormation templates, you will reach to this page. You can either look at some snippets. So when you're writing CloudFormation, you can refer to the snippets and create your own. You can also use a CloudFormer or a designer here. So from the CloudFormation UI, You can click on design template, which opens up a UI editor, and you can define or choose your own resources here, including, let's say I want to create EC2 instance. You can drag and drop here. You can drag a network policy, security group, interfaces, assign it to that, define a VPC, and design it, which can get then translated into the template here, which will look like this. That's the simplest way of creating the CloudFormation template, either using JSON or YAML. I personally prefer YAML because it's easily readable. But if you use JSON, that also works with or is supported by CloudFormation. And these are some of the sample templates. I'll just show you one template here. You can also open it in a designer. If you're logged in, it will automatically take you to that CloudFormation designer. And this is an example of that WordPress template. This is how it will visualized. And you have dependencies, you have defined configurations for each of this, which is shown here. And that's what you see here. So it has the template version, description, parameters are the input parameters. So you can define your instance type, the key name, and the SSH location and DB users and so on and so forth. And then you can launch your own WordPress. This is the mapping. So if you choose a particular instance type, it will use a different type of virtualization virtualizer and choose the image accordingly. And this is where you define how do you want to configure it, what you want to configure on that WordPress instance, and based on that it will show you the outputs as well. And how do you launch it is, let's say I have this S3 URL for the template. I can go back to the CloudFormation UI, go back to the main page of CloudFormation, and create a stack from here. Choose my template. That could be your own template, or you can just define a URL. And if you click on next, it will validate that and it will ask you for the inputs. Now these are the same inputs that we saw here. So even though it looks a little complex kind of a code here, when you start using it, and mostly you will be using it once you've written the template, and when you write the template, you can use a lot of snippets or the visual designer. And this is where you define the database password, database user, instance type. Based on that, it will automatically be mapped. And then when you click on next, it will ask you a few more things, and it will let you verify, after which it will go ahead and provision that stack. So this is a way to automate it. You can revision control this code, share it, and then you can create a repeatable template when you want to provision any of your infrastructure stacks. And that's how CloudFormation works in a gist. So we have discussed so far the most fundamental services, including IAM, S3, EC2, RDS, auto scaling features of EC2, CloudWatch, and few other DevOps services as well. Now, what are the additional services that you should know about? Now, some of these are essential for a lot of and work with a lot of other services that we've been using so far. And we're going to look at some of these specific things. Let's say for databases mainly, or for a lot of applications, if you want to do in-memory caching, you have a managed version of Memcache or Redis in the form of Elasticache. Now, Elasticache goes along, it's part of the database services, and it goes along with a lot of applications where it takes the load off the database by caching the objects in memory. Now, a lot of application, especially when we talk about loosely coupled architectures, rely on the messaging services such as the RabbitMQ, ActiveMQ, and a lot of different queuing services. Now AWS has its own queuing mechanism or a managed service called as SQS. That stands for Simple Queue Service, and it's again sort of a managed service for which is used by a lot of applications there. Another service which is essential for a lot of other applications, including auto scaling, including monitoring, CloudWatch, and other messaging services, emails that you want to send, is email service, that is simple email service. And this is purely a SMTP or API, something like SendGrid, with high credibility servers. Why you should use SES instead of hosting your own email server is, one is this is managed, second it's scalable, third is it will guarantee that your email lands up in the inbox and not in the spam directory, which happens with a lot of low credibility servers that we have, which we host ourselves, right? Since Amazon's email servers have high credibility, which are accepted by Google and Gmail and a lot of other email services, those are generally considered to be better. And where do you use SES services is, let's say you have an application and it sends subscription emails, confirmation emails, any of those emails that you want to send to your customers, to your users, you would want to use SES for sure. Now, apart from these, there are many other services which are useful. If you go to just aws.amazon.com, you'll find a list of the complete set of services available here. Compute, we looked at EC2, storage as S3 and EBS. Another interesting service is Elastic File System, which is like a managed NFS server. These are network file storage. We've looked at Glacier as well. In terms of databases, we've looked at the RDS as well as the Elastic Cache. There are certain services which are useful for migrating. Let's say you want to convert your schema, migrate the database, migrate the servers. You may want to use some of these services. We've talked about these in DevOps services, most of these like code build, deploy, pipeline, and commit. Apart from that, if you want to host your DNS, you have a Route 53 DNS service. VPC is something we have covered apart from, in addition to load balancing too. Talking about management tools, CloudWatch is the monitoring system, and apart from that, you have CloudFormation, OpsWorks, which we have looked at, and then there are some other managed services like AWS Trusted Advisor, the Service Catalog, Config, which you might find useful to keep track of your infrastructure and manage it effectively. Now, if you have specific kind of applications, let's say AI applications, you may want to consider some of these like Poly and some voice recognition, machine learning, and TensorFlow. That's the quite popular one from Google, right? So that's one. Analytics, you have a bunch of Hadoop and managed EMR. That's a EMR service, Cloud Search, Kinesis, Redshift. There's a data pipeline and so on. Security wise, we have looked at the IAM mainly. But there are few other, identity compliance and security services. Apart from, if you are building mobile applications, you may want to consider these. So these are again specific to the kind of applications that you have. Apart from that, you can explore the cost. You have application services. Messaging is something that we just looked at. Business productivity, where you can host your work mails, documents, and desktops as well on cloud, and so on. And then there's a new IoT related services that AWS offers apart from what we looked at so far. So that sort of gives you a gist of what are the services, what kind of categories that you have, as well as some of the additional useful services that we talked about. So CloudFront is the content delivery network provided by AWS. Now, what do you use content delivery network is to provide a global network to host your data and to distribute it to your clientele across the globe. An example of that could be, let's say you have a soccer match, which is viewed by, like millions of viewers across the globe, but the match is happening in one place. That could be, let's say, some place in Europe. Now, what happens with CDN is, even though the origin can be one place, it gets distributed and you store that data, you cache that data for distribution, in a sort of a globally replicated centers, and those are called as edge locations. And edge locations act as a cache, and edge locations are available. For example, AWS has tens of edge locations, like there are 40-50 edge locations across the globe, and anybody who is viewing from that country, from that geography, instead of going to the origin and choking up the bandwidth there, they go to the edge location. And that's how the distribution happens. So let's say there is a streaming service which is which has been hosted in one place. It gets replicated automatically. There might be some lag of few seconds to few minutes, but it is it streams continuously, and it's faster because you have less number of hops, as well as you have a cache which is closer to your location. And that's how the CDN, or the content delivery network, works. And in addition to this, you also have services which automatically detect your IP. And based on your IP, the location and geotagging is done. And based on that, it automatically gets redirected. One of the alternatives to a CloudFront, one of the most popular services in the world of content delivery network, is also Akamai. And there are two different types of distributions that the CloudFront supports. One is the streaming distribution, in which case it's a live game, for example, that's a streaming match. The other is download. Download is basically you store it and you watch it later. It's not live store. In case of streaming, you also need a streaming server like Adobe Media Server or streaming server, which could be used to stream this live. And a lot of companies today use content delivery network to not only speed up their distribution, but also to avoid the load on the central or the origin server that we have. Now, you can choose the distribution option in case of CloudFront. You can choose to use, let's say, US and Europe only, or US, Europe and APAC, or you can define all, in which case it will be distributed all across the globe, all the content delivery or all edge networks or edge locations across the globe. Now in this lesson, we're going to talk about what are the best practices for designing your infrastructure and the application architecture in general on cloud. And this is not only applicable for AWS, it could be any cloud native application that you might want to look at. We've already looked at the advantages with the cloud. Now, talking about the best practices, I have a list of things that I would recommend in terms of best practices from my own experience, as well as from the best practices followed by the architects across the globe. First being design to scale. So when you design your architecture itself, you must consider the horizontal scaling instead of vertical scaling. You must leverage or start considering some of the features that AWS gives you in terms of the scalability, like auto scaling, multi-AZ, databases, read replicas, creating those kind of infrastructure. Also, your application could leverage things like queuing systems, as well as loosely coupled architecture. You can consider the NoSQL instead of SQL databases. You can use the load balancers and so on and so forth. Your application as well as the cloud system infrastructure should be built with the scale in mind, even if you start with a small scale infrastructure, because it's much difficult to convert your infrastructure, modify it later when you actually need to scale and you're at the point of at that point, right? And you should consider performance, the heterogeneity, operational efficiency, resiliency. The infrastructure should be resilient to the failure, so you should have those resiliency built into the infrastructure. As well as the cost effectiveness, using features such as auto scaling and ECS for Docker based infrastructure. And talking about ECS and Docker, it makes sense to use microservices based loosely coupled architecture, where instead of having a monolithic tightly coupled application, you have a loosely coupled services based infrastructure, and it can be each of that application, each of that layer can be scaled independently, can be replaced with, let's say, a managed service or some other application, and using containers, Dockers from that perspective becomes essential. Having a stateless application instead of stateful also makes a lot of sense. If you want to, have a state, it should generally be stored on a disk, which is a network disk, or in a in-memory caching server, in a queuing system somewhere, or in a database separately, instead of having that state stored on that server itself. So servers should be treated as the compute units which come and go, and the actual data that you care about should be stored, and the state should be stored somewhere else. There is a limit on scaling vertically. Vertical scaling is generally you have a small server, you create a larger one, and then you go to extra large and double extra large and so on. So you will hit a limit or the ceiling at some point of time, beyond which it will be extremely difficult to scale for you. It will also be a costly affair to do that, and it can create single point of failures too. So the best way to avoid all this is to create horizontally scalable architecture, and that's where NoSQL comes in handy. That's where queuing systems come in handy. That's where loosely coupled scalable, horizontally scalable architecture makes a lot of sense. So you should think about scaling horizontally than vertically. That will have no limit in terms of how much you can scale. You should design for failure. That's the resiliency we talk about, right? And one of the examples of how Netflix does their architecture is they introduce this chaos monkey, which goes and kills certain part of their infrastructure randomly, just to make sure that you are able to, mitigate that failure in an automated way, and your systems are fault tolerant and resilient to such random failures, which can happen anyways in a random way too. And that's what you should do. You should build your infrastructure, you should design it to be resilient, and make sure you test it. Now, when you talk about cloud and cloud scale and cloud native application, it becomes pertinent to automate everything, and that's where all these DevOps practices such as infrastructure as a code and revision control system and using CI/CD in your application build and pipeline come in very, very handy. So you should try and automate everything that you're doing, which you spend a lot of time on, and should be done in an automated way. Monitoring everything is another important aspect. So when you design your infrastructure and architecture, you should make sure that you have built your monitoring into it, and that it could be monitoring not just the health and uptime. It also could be related to monitoring the logs, monitoring the application performance, and various other aspects of your infrastructure and the operations. Now, another suggestion I would give is use as many managed services as possible and practical, because that will save you tons of time and efforts and money in order to manage this kind of infrastructure. And you can actually manage with less number of resources, human resources, who can build and manage and design this infrastructure. And a lot of times in the world of DevOps, developers will also be responsible for building and deploying to production, in which case using these managed services becomes essential or really a value add. You should also parallelize things. For example, if you're uploading data to S3, you can in fact run it in parallel, and it can get you 2x, 3x, 4x the bandwidth that you're using right now. Similarly, you can parallelize the operations using a lot of parallel processing, and there are many applications which support that. And using parallelization can again save you a lot of time and the latency. Now, talking about data placement, you need to define it in a right way. So, if you have a dynamic data, it should be closer to the compute, because the compute instances, compute servers, which are going to need to process that data, and for that you can use a better storage, or you can use provisioned IOPS. You can store it using instance store, or whatever gives you a high IO bandwidth. Whereas if there is a static data that you want to serve to the users, it should be stored closer to the end users. What do you mean by that is use content delivery network, so that when the user fetches those videos and the images, it comes from the closest edge network that you have, right? So in terms of data, if it is dynamic, keep it closer to compute. If it is static, it should be closer to the end users. Now, when you talk about building a resilient, fault-tolerant, highly available application, your disaster recovery resiliency should be considered as well. And for DR and high availability, we generally use regions and availability zones that AWS offers, along with the rest of the features such as auto scaling. For disaster recovery, you should generally consider multi-region. In some cases, you should have multiple accounts as well to store data from one account to another, so that even if one account is affected, you should have another account there. And for high availability, you should definitely use the availability zones inside the regions, and that way, even if one availability zone is affected, it does not hinder your application. On the other hand, if you use regions for HA, it becomes expensive because the traffic travels over the internet, so that's not feasible and the right choice to do it. You should use availability zones for HA and regions for DR or disaster recovery. And those are some of the architectural design ideas and best practices that that you could refer to. Apart from this, if you are an architect, you should definitely look at AWS Architecture Center, which gives you tons of resources related to this, including how people are building their own infrastructure on AWS, how they are architecting it. There is a theme of the month which talks about microservices, which is the in thing right now, which is the right, which is where a lot of companies are moving toward. There are some architectural references too. There are blogs, there are reference architectures which you can go and look at as well. Let's say I want to build WordPress hosting. What are the best practices related to that? I can look at these sample architectures, and based on that, you can build your own system architecture. Right. So from that perspective, using Architecture Center is great. It also gives you some resources when you want to design your architecture, draw your architecture. There are essential and useful resources which are available here. There are some solutions, case studies, etc. as well. So this is a great place if you are a system architect and want to build your application on cloud, not necessarily on AWS, because you can build similar architecture or design it off cloud as well, or on a different cloud too. But these resources are immensely useful. And then especially these ones are pretty good, and these I generally use this as case studies for my architectural workshops on AWS, which turns out to be very, very interesting all the time. And that's some of the resources that you would need as an architect.